The struct feature and concept, which we explored in the previous course sections, is one of the most important concepts in Go. You will use structs very often to group data together. But there are more data structures in Go which also have their place. And in this course section, we will learn about arrays, slices, and maps. And of course, we'll learn when we need those data structures and why we might want to use those instead of structs. And for that, in this course section, we are going to start with diving into lists of data and how we can manage such lists with arrays. We are then going to learn how we can use slices to work with arrays in a more flexible way. And last but not least, we're also going to dive into maps, yet another data structure built into Go, which also has its place and purpose. Now, as in every course section, I got a brand new project. Just created a Go module with the go mod init command. And I want to start with lists of data, with managing lists of data and what I mean with that. And for that, I'll add a lists.go file. And in there, as always, I'll add my main package and then also my main function because we'll still need that. Now, what do I mean when I say lists of data? Well, let's start in a different way. We did learn about that struct, where we maybe have a product, and hence we have our struct, and in there we then have a title for the product, and maybe an ID, and maybe a price, which is a float. That's what we saw before in the course. The struct concept or feature is a very useful feature because it allows you as a developer to group data together. We group a title, an ID, and a price together into one data package. And organizing data like this is super important because very often in your programs you have more complex pieces of data that you want to express. But in a nutshell, a struct is a data grouping mechanism. And we do group different kinds of data into one piece of data. A title, an ID, and a price are very different data pieces that are grouped together into one data piece. That's how you can think about a struct. Now, in some programs, actually, as it turns out in a lot of programs, you don't just need such kinds of data groups, but sometimes you also have similar pieces of data that need to be grouped together. And that might sound very abstract, so let me give you an example. What if we would be building a Go application that's dealing with some data analysis? And therefore, as part of this application, we might get various values. For example, some weather data, maybe some product prices, which we want to analyze. Doesn't matter. We get different pieces of data. Let's say different numbers. Now, they all express the same thing. For example, if we get temperature values, every number might express a temperature in Celsius or Fahrenheit. But we, of course, have different values. Now, if we work with such kind of data, where we have many values that describe the same thing but have different values, then a struct won't help us. We could, of course, create some struct temperature data like that, and in there have the temperature of day 1, which holds, let's say, a float. And then we have day 2, which holds a float. But doing it like this, solving this problem like this, would be very annoying. Because we have to know in advance how many days of data we want to have. And even if we do know that, we have to do a lot of typing to describe all those days, to set up all these day keys. So that's very annoying. It would lead to a lot of code and to code that's quite unreadable. And working with that kind of data would then also be a bit annoying throughout the application. That's why for such cases, where we describe the same thing and we just have different values, we have a different kind of data structure built into Go. And we have this kind of data structure in basically every programming language out there. It's just a name that's different between all those languages. We have a so-called array. In Python, it would be called a list. In JavaScript, it's also called an array. And an array is a data structure that holds values, potentially different values, that kind of describe the same thing. Now let me show you how we create such an array. For that, I'll create a brand new variable that will hold my array, and let's say we want to work with a bunch of prices here. But of course, it's up to you. Here, I'll just go with some prices, and let's say that should in the end be a list of floating point values, so a list of floating point numbers that we want to store in this prices variable. Now, since it's a brand new variable, we'll use the := operator to create it and set a value immediately. And now we can turn this into an array by using a special syntax. We want to have a list of floating point values, as I said, so I'll type float 32 or 64, doesn't matter. And then in front of that, we add square brackets. This is an important piece of syntax that tells Go that we don't want to create a single floating point value that should be stored in prices, but instead a list of floating point numbers. Now, between those square brackets, we then have to tell Go how many values we want to store, and let's say that's 4. So we want to store 4 floating point values in a list of floating point values inside of prices. Now, it's still not all. When using this syntax here and immediately assigning a concrete value to prices, which is what we do with this operator, we also have to let Go know which values should be stored in this array. And for that, we add opening and closing curly braces here. Now here, between those curly braces, we can now enter the values that should be stored in this list. So something like 10.99, 9.99, 40, 5.99, and let's say 20.00, or just .0. This now creates an array, a list of 4 numbers, 4 floats that's stored in prices. And you can create arrays based on any kinds of values, not just floats. You can create an array of strings, of integers, even arrays of structs and other arrays, so-called nested arrays, are possible. But let's start simple. Let's take a look at what we created here by using the format package and calling the println function, to which I then pass prices. And now we're not using this struct anywhere, so therefore I'll get rid of that since it was only there for demo purposes anyways. Now with that array created, if we open that terminal here, if we run our module, we get that list of data output here. And that's how we can create such a list of data. And the key difference compared to a struct really is that all these values describe the same thing, a price. But of course we describe different prices, and hence we have a list of these different values that describe the same thing. And that's a fundamentally different idea than we had it with a struct. And different scenarios and use cases in your code simply require different solutions. Now let's take a closer look at this array thing and what we can do with it and how we can create it. Because here we only see one way of creating an array. We can also create an array by using the var keyword and then giving the variable any name of our choice. Let's say we have a couple of product names, so I'll choose product names here. And now I don't want to initialize it immediately, I just want to declare this variable and make it clear that it should contain an array as a value. So it's not a string, which would be a single value, but instead an array of strings. Same syntax as down there. Square brackets in front of the type of value that should be stored in that array. Now, when creating such an array, you also typically want to set a length for that array so that it's not an empty array which has no items at all. And you do that by adding that length, so the number of items that should be stored in that array, between the square brackets. So we could use 4 again or 3. It really depends on how many items we want to store. Let's go with 4 here. With that, I'm creating this array, and if we now print that without assigning any values, if I print my product names like that, and we then open that terminal again, if we run our code, we see this. It's very important to note that the program doesn't crash or anything like that. Instead, the null value that's now set for product names is now simply an array with 4 empty slots. And that's what this in the end represents. Now, of course, we could set product names equal to an array now by, again, let's say, creating an array like that. And then we could pick different names like a book and so on. And you also don't have to set all the names. If I just set one name and I run this program again, you see one name is set and the other slots are still left empty, so that's possible. But you also sometimes have the scenario that you want to set specific values. Let's say the second value in an array. Or you want to read a specific value instead of outputting the entire array. And therefore, that's another key mechanism that you need to know as a Go developer. How you can target individual values in an array so that you don't always have to set or read the entire array as we're currently doing it. Now, for that, first of all, to get rid of those yellow squiggly lines, I'll merge this into one line here, like that. And then I want to show you that syntax for accessing individual items. Let's say we want to print the third price in the prices array. So here I want to print prices, but not the entire list, but just the third value. For that, we got a special notation that allows us to access a specific value in an array. We again use square brackets, but now not to create a new array, but instead after a variable name that holds an array to tell Go which specific item we want to access. For a struct, we used the dot notation, but for arrays, that's not available because arrays are not structs. Instead, for arrays, we use square brackets. And now we also don't have key names for those different values. I mean, where would those key names be? But instead, all those values have unique index values, which are automatically assigned. And the logic here is very simple. The index values always start at 0 for the first element. And that can be a gotcha. It's not 1 for the first element, but 0. So if you want to output the first element, you would write prices and then 0 between square brackets. So if you want to output the third element, we need which value here? 2, because we have 0, 1, 2. This has an index of 2. So that's how we get access to the third element. And that's just something to keep in mind. Thankfully, it's the same in most other programming languages that arrays or lists, or however that feature might be called there, start at index 0. So with that, if we save this and open our terminal, if we now run this program again, we see that 45.99 is being output. And that is how we can create arrays and how we can read single values from arrays. We can, of course, now also set single values. For example, if you want to set, let's say, the third product name, we did set the first one thus far. The other slots are left out empty. If we want to set the third one, we can set product names and then again target the third element, which still has an index of 2, and set this to a specific value, like a carpet. Now on product names, we'll have the first value being set and the third value being set, and the second and fourth values will still be empty. But that's fine, that is something you can do. With that in place, if we run this program again, we output a book, then our empty blank slot, then a carpet, and then another blank slot in this array. That's how that works, and that's how you can work with arrays. But that's far from everything that you need to know about arrays and that you can do with arrays. Arrays are extremely important and useful, and that's why we have more features related to arrays that also are important to understand. Specifically, we have the slice feature. That's a key feature of Go and a feature you'll use a lot. Now, what's a slice? Here we have two arrays, product names and prices. Now, thus far, we learned how we can work with the full array, for example, to output the entire array, or how we can target individual values, like we do it here. Sometimes you also need a subset of an array, so a part of that array, more than one value, but not the entire array. And that's where a slice comes in. Down there, I want to create a slice of my prices. Let's say we want to fetch these two prices, $9.99 and $45.99. So we want to create kind of a new array based on this array that omits the first and last values. That's what a slice can do for us. So let's say our featured prices should be that slice. So that's a brand new variable, which I'll therefore create with the colon equals an operator. And we now can create a slice, so create the value for featured prices based on this prices array by referring to that prices array, and then again using that square bracket notation. But now instead of targeting a single value, like the second or third value, we can now also use a slightly different notation. We can type 1:3. And that creates a slice from that target array, which means we'll take a look at that array, and then we'll start at the element with index 1, which, as we learned, is the second element. And then we take all the elements up to the element with index 3, excluding that element though. So the first value is always included, the second value is excluded. So this notation would start at the element with index 1, and then would go all the way up to the element with index 3, which in this case is 20. That will have an index 3 since it's the fourth item, but will not include that item but exclude it. So that will create a brand new array, though it's technically called a slice, that will only contain these two values in the middle. So if we now again output that, if we print line featured prices, if we run this program, we see this slice being output here. And of course, that is just that middle part of our original array. And slices, therefore, are another core feature, since in a lot of applications you do need to work with parts of lists. And slices allow you to easily create brand new lists based on other lists of data. Now, slices are extremely useful and versatile, and there is way more you can do with slices, and you should know about slices. For example, regarding that syntax here. We learned that we can start at some index and end at some index, excluding the value at that index. But you can, for example, also omit the starting index and just write colon and then the end index. If we do this and we run our program, then you'll see that what we get is this kind of list. So it's almost the entire original array, just the last value, the 20, is missing. And the reason for that is that this notation tells Go to start at the beginning of the array or slice which we are targeting, and then go all the way up to some element with some index. You can also do the opposite and maybe start at the element with index 1, so not the first element, but the second element as we learned, and then go all the way to the end of the array or slice which we are targeting. If we would run this code here, we get the end of that original array. We get this part here. So these are things we can do. What you can't do here, and what you can do in some other programming languages, is use negative indexes. So you can't start at the last element with a minus or something like that. That works in some other programming languages. It doesn't work here. What you also can't do is pick a higher end index than the original array has. We already get an error here that it's out of bounds. So the highest value you can select here really is the end index plus 1. Plus 1 because the last element by default is excluded. So to give you a way of targeting that last element as well, Go allows you to pick the index of the last element, which would be 3. The last element here has an index of 3, and add 1 to it. That's the highest bound. Now we get started with slices and arrays. Time for a brief look behind the scenes to fully understand the connection between slices and arrays. Slices are like a reference, like a window into an array, a bit like a pointer, though it's a different concept. When we create an array like prices, that array is stored in memory. When we then create a slice based on that array, we get a window into that array, so to say. And therefore, if we would modify an element in a slice, we would also modify the same element in the original array. So for example here, if I use my featured prices slice, which again is this part of the original array, and I added the first item of that slice, which is $9.99, because we start at the second element here when we select that slice, which is $9.99. So the first element of that slice then is that $9.99 value. If I added this and set it to 199.99, then indeed what you'll see is that when we output the prices array, so the original array, which I did not directly edit here, we will still see that $9.99 will have been overwritten by 199.99. So if I run this program, indeed we see that the original array has its second value overwritten by this value, because a slice is just that window into the original array. And that also has one important implication. When you create a slice, you don't copy the original array. So you don't have that copy in memory that occupies extra memory space. Instead, you still only have one array in memory, and your slice is just a tiny reference to a part of that array. And hence, it's a very memory efficient way of selecting parts of arrays, and if you want to do that, of editing parts of an array. Now, Go also saves some metadata for our slices that can be useful to look into. For every slice, we got a length and a capacity. And we can output both here to understand what it is. I'll start with the length. The length of featured prices can be output by using the built-in len function, which is built into Go just like that. You don't need to import any package for that. It's a default Go function. You can also call it on other value types, as you see here in the tooltip, for example on arrays and also on strings, but here we'll just call it on the featured prices slice. And then I want to output a second value, which we get by calling the built-in cap function, which just like len is built into Go. To cap, I'll also pass my featured prices, and that will give us the capacity. Now here, if I run my code, we'll get the same value twice, will get free twice for both the length and the capacity. But what are these two values? The length gives us the number of items in a slice or array. So if that slice, featured prices, has 3 elements, which it does, length will give us 3 as a value. The capacity is a bit more complex. It's the same value here, but that would be different if we would output highlighted prices. If we output the length and capacity of highlighted prices, then we'll see a difference. So if we use that other slice we got here. Here, if we output that, we get 1 and 3 as values. Now, why is that? Highlighted prices is based on featured prices, which in turn is based on the prices array. So they share the same array under the hood. But highlighted prices selects everything from the start of featured prices up to the second element of featured prices, excluding that element. That's why we have a length of 1. There is only one element which is part of that highlighted prices slice. But we have a higher capacity because the slice, and therefore the original array on which highlighted prices is based, actually has more items left. In featured prices, where we selected everything from the second item until the end of the original array, we still have this entire subset left. So if in highlighted prices we then select just the first item, we could theoretically still select the other 2 items, and that's why we overall have a capacity of 3. Why not a capacity of 4, since the original array has a length of 4? Well, because, and that's important to understand about slices, you can always select more towards the end of an array, but not towards the start, so towards the left. Since the first slice on which we are based starts at the second element and not at the first element, any other slices based on it can't go further to the left. So we can't go back to that first element which we omit here. That's why the capacity only counts towards the end of the original array, but omits any elements that might have been filtered out before. Can be a bit complex to wrap your head around, but is something you can simply play around with in code as well to get a feeling for it. In the end, it's just important to understand that you can always select more items to the right, but never to the left. And to show you what this means, I'll change highlighted prices. Here, after outputting all of that, I'll use highlighted prices, which is based on featured prices, and I'll set it equal to highlighted prices, so not featured prices, but highlighted prices, and then select everything. Select a specific index, like 3 here. And now, if I repeat this code here, without outputting prices again though, you will see that if you now run this code again, you get that entire featured prices slice. And now the length matches the capacity. Now that is a quite interesting behavior because I did now reslice highlighted prices based on the previous highlighted prices slice. It might have been clear that this works if I would have used featured prices here, but I did not do that. I used highlighted prices here. And highlighted prices before, in this code block, was just one value, because we sliced it to be only up to the second value. That's what I meant with you can always select more towards the end of an array or slice. Even though highlighted prices originally only had one element, we can reslice based on that one element slice and now suddenly select more than that one element because internally Go always memorized that there is more content available to the right of the selected slice. And that's what this capacity here kind of told us, where we had a difference between capacity and length. There were more elements available and Go memorized that. That's why on this one element slice, we still are able to reslice to pick up more elements, but only to the right, not to the left. There is no way of getting access to this original first value in that prices array. That's gone forever since we started by creating a slice that omitted that value. And that's a lot of deep dive theoretical stuff. I'm fully aware of that. These are just some gotchas and interesting quirks for that slices feature that you should at least have heard about. Because sometimes when you write your own code or you dive into other Go projects, you might suddenly see code snippets like this, where we suddenly select more than was previously stored in a slice, and you might wonder why that works. Well, it works because if you select more to the end of an array, you can't always do that because Go memorizes that original array. But as a special quirk, it kind of only does that for more values to the right of the existing slice, not to the left. So that was a lot of deep dive stuff on slices, and you won't need all of that all the time, but as I mentioned, you should have at least heard about it. Now, slices are not just a useful feature because you can make other people dizzy by diving into slices on slices and stuff like that, but also because with slices you can create dynamic arrays. Because let's come back to that original prices array. One downside of using that array was that we had to define ahead of time how many values we'll have in there. Now, sometimes in the applications you're going to write, you know exactly how many values you'll have in a list of values. For example, if you handle some user input in a form that has exactly 3 form fields, you might have an easy time storing those 3 values in an array because you know ahead of time that you'll get 3 values. But let's say you're loading a list of prices from a database, and the data in that database changes frequently. Then when you write your code, you don't know ahead of time whether you'll need 4 or 5 or 100 prices. So having to set the length of an array in advance in your code can be a restriction that's quite annoying. In other programming languages like JavaScript, you don't have that restriction. There you can create an array and it's automatically dynamic. So you can always add and remove elements just as you want to. For Go arrays, that's not the case. Prices is an array with 4 elements, and you can't just add a 5th element, even if you wanted to do that. Now, since we have that restriction, Go thankfully also has a solution for us, and that solution again is that slices feature. Now, I'll comment out this main function because I want to keep it here for reference, but I don't want to execute it anymore. Instead, I'll write a brand new main function so that we have an empty, cleaned up main function to dive into that slices for dynamic arrays feature. Let's say we again have some prices, but this time it should be a dynamic array where we can add more values whenever we need to. You can create such a dynamic slice with a syntax that's similar to what we saw before, so square bracket, float 64, curly braces, but you may now also omit the length here. If you don't specify the number of items that should be stored in this array between those square brackets, Go will actually automatically create a slice for you, and since a slice always is based on an array, it will also create an array for you behind the scenes, but it will automatically ditch that array and create a new array if your slice grows beyond the bounds of that behind the scenes stored array. But we'll see that in a second. So here we can create an empty slice like this, or maybe even populate it with some starting values. Both is possible. Now we can still work with that as before. We can build slices based on this slice. We can select individual elements. So for example here, I can print prices 1. And if we run that code, unsurprisingly, hopefully, we see 8.99. Now we can also select a slice here if we want to, like this. And if we execute that, we see 10.99. So that's still possible. That all works. Now we can, of course, also assign values like this to override the second value. But what we can't do is assign values to indexes that are not part of the slice. If we would try to do that and we then output prices thereafter, it crashes because the index is out of range. I don't get this error in the IDE, but I get it when I try to execute that code. So we still can't access indexes that don't exist. But I told you that this would be dynamic, right? But not like this. Instead, there now is a built-in function in Go, the append function, which you can execute like that, which, as you see here in the tooltip, wants a slice as a first value, and then a list of elements that should be added to that slice. So here we could refer to prices, which is a slice, as I mentioned. This syntax creates a slice, and Go creates the array that belongs to the slice behind the scenes. And now we can, for example, add 5.99. And that will now append a new item, but it will actually also return a brand new slice. So it actually does not edit the original slice, but instead what append does is it tells Go that we want to add an item to that slice, and therefore also to the underlying array. Now, of course, an array has a fixed length. So what Go will do in this case is it will create a brand new array and add that element to that brand new array, which is created such that it has the capacity for that new array. So here I got my updated prices, and I can now print my updated prices here if I want to. With that, if we now run this program, we see that we got our updated prices here, which is the original prices, slice, and therefore array, plus the 5.99. Now, if I would print prices here as well as updated prices, so if I print the original slice and this new slice, you see that the original slice did not change. This is still just these two values, just 9.99 instead of 8.99 because we overwrite this here. But the original slice and array was not changed by Go. If you wanted to do that, you would have to instead reassign this appended slice to the existing prices slice instead of creating a new variable. Then, of course, if you do this and you output this prices slice, then you'll see that it changed. And again, Go will manage the arrays for you behind the scenes. And if you reassign an appended slice to an existing slice, it will of course also ditch that original array, which only had 2 elements before, and use that brand new array that holds that extra third element for that slice instead. So memory management is taken care of by Go here. And since we now have that extra flexibility where we can always add new elements if we need to, it's way more common to work with slices right from the start in Go than it is to use arrays. You can still use fixed length arrays if you know for sure that you will never have more than X amounts of elements in a list. But if there is at least a slight chance that you might want to add new elements as your program executes, you should definitely go for this slices approach right from the start instead. Because that allows you to add elements to slices and to let your arrays grow just as they need to. Now, in case you're wondering whether there also is a function to remove elements from a slice, since there is an append function, well, yes, kind of. We can, of course, just create a new slice that removes the element we want to remove. If we want to remove the first element, we simply create a new slice based on the existing slice that starts at the second element and selects everything up to the end. That gives us a brand new slice that omits that first element. So with that, we of course did remove that first element, which was 1099. So that works like this. There is no function for doing that since we already have the built-in mechanism with that feature that allows us to build slices, this slicing syntax here. Working with arrays and slices is actually not that difficult, but we did learn a bunch of very important concepts over the last minutes. And hence it's time to practice what we learned. Attached you find this practice.go file, which contains a pretty empty, Go code file, just with the main function and main package, but which also contains a lot of instructions that allow you to practice what you learned. And as always, you can then go through my solution lecture to compare your solution to mine and see how I solved this. Now, in this exercise here, I want you to start by creating a new array, very important, an array, not a slice, that contains 3 hobbies that you have, any hobbies of your choice. So create such an array with an appropriate length and value types being stored in there, and then output that array in the command line. In task number 2, you should also output print the first element and just that element, and then also the second and third element combined as a new list. So you should also output these pieces of information. In task number 3, I then want you to create a slice based on the first element of that array that contains the first and second elements. So start at that first element, but make sure you also contain the second element. Now, very important, I want you to create that slice in 2 different ways. So in the end, you should create 2 slices, though you can comment out one of the 2 approaches so that you're left with 1 new slice in the end. But create it in 2 different ways because there are different ways of selecting the start or the first element of an array and so on. So find 2 ways of creating a slice based on that first array here that contains the first and second elements. Also output that new slice once you're done. In task number 4, I then want you to reslice that slice from task number 3 and change it such that it contains the second and last element of the original array. So don't create a slice based on the original array itself, but create a new slice on that existing slice which you got from task number 3, but change it such that it's the second and last element instead of the first and the second element which it was before. And then also print that updated slice. Now in task number 5, you should create a brand new array, but a dynamic array, and therefore it's maybe not really an array. You learned what you'll need. And that should be a dynamic array that contains your goals that you have for this course, and you should at least add 2 goals into that dynamic array right from the start. Also output that array thereafter then. In task number 6, I want you to overwrite the second goal in that array which you created in task number 5 and set it to a different goal, and also add a brand new third goal to that dynamic array. So that's what you should do in task number 6, and then output that updated dynamic array. And then I got a bonus task for you. A bonus because you'll need to do something which we haven't done before. I want you to create a product struct, that is something we did before, which has a title ID and price. And then you should use this struct to create a dynamic array, a dynamic list of such products, at least 2 products. And then I want you to add a third product to this existing list of products. Again, that is something we haven't done before, so maybe you find a way of achieving this. Otherwise, I'll show you how that works in my solution. So, did you succeed? Let's now solve these tasks together. And let's of course start with task number 1. In task number 1, we want to create a new array that contains 3 hobbies. So I'll create that array, and we get various ways of doing that with the var keyword and this slightly more longer syntax, or we use the very concise syntax where I create a hobbies variable and we use the := operator to then create that array. Now here for task number 1, we need a real array. No slice, but a real array, as I highlight here, and therefore we wanna define the length of that array, so the number of items that will be stored in it in advance. We also need to define the value type in advance. That's the case both for dynamic arrays, slices, and real arrays. And here, since I want to store some hobbies, so some text in the end, string sounds like a fitting name. And then you learned we need the square brackets in front of that. And since we'll have 3 hobbies, I'll add a 3 here, and then curly braces like that. Now we can set our different hobbies by accessing the different indexes and setting it like this. Or we set it all in one go and have something like sports, cooking, and reading as hobbies here maybe. And then of course we don't need a deadline unless we want to overwrite the first element. Now we created that array and we want to output that array, so with help of the format package and the printline function, we can now print hobbies. And that should be task number 1. Now to see it in action, I'll run this module, and for that I actually need to init my module first of all, which I haven't done before, so let me quickly do that with some dummy identifier, and then I can run this module. So now we see sports, cooking, and reading here. This is working. In task number 2, we now want to output more data from that array. The first element standalone, and then the second and third element combined as a new list. So for that here, task number 2 involves some printing. But now I want to access the first element. And you saw the syntax a couple of seconds ago actually. We can access specific elements in an array to read or set them by using square brackets after the variable name that contains the array. And then we use the index of the element that we want to read or write to. Now the index, that's the important thing, starts at 0. So if we want to read the first element, we don't use 1, but we use 0 instead. And this will now output the first element. Now that's not all though, we should also output the second and third element combined, and for that we'll need a slice, because we learned that with a slice we can select a subset of an array and then work with that. So if you want to select the second and third element, then we want to start at the element with index 1, which is the second element, and then select everything up to another index. That index will be excluded though. So if I would write 1:2, we would not select the second and third element, which you might think, since we have the indexes 1 for the second and the index 2 for the third elements. But instead, since that element will be excluded, we would just select the first element. Instead, we need 3 here, so the index of the last element plus 1 to select that last element and include it in that slice. Or we use the shortcut and just type 1:nothing to select everything up until the end of that array. Now here I'll go for the more explicit syntax, but either of the two approaches is fine. And with that, just to quickly check that, if we run this, we now see sports, which is that first element for line 11, and then cooking and reading, which are the last 2 elements, so the second and third element for this line of code here. So that's also working. In task number 3, we should now create a slice, another slice, based on the first element, so based on that first array actually that we have here, that contains the first and second elements, instead of the second and third elements which we have here. So in task number 3, I'll add a brand new slice and now also store it in a variable. And I'll name it first hobbies or main hobbies maybe. Create a brand new variable and then use my hobbies array and create a new slice. Now to select the first and second elements, I want to start at the index 0 and then select everything up to index 2, since that will select everything up to the element with index 2, which is the third element, which is then excluded, so it will select the first and second element successfully. Alternatively, here we omit the 0 to start at the beginning of that array on which this slice is based, and then just go up to the third element and exclude that element. Either way, we'll select the first and second element, and with that I also show you 2 approaches of making that selection. And then we also want to print that so that we don't get an error, and print main hobbies here. And now if I zoom out a bit so that we have more code on the screen, if I run this code again, we do get sports and cooking here, which indeed are my first 2 elements. So that is also working just as it should. Now, task number 4 wants us to reslice 3 and change it such that we contain the second and last element now, instead of the first and the second element. Now that works because behind the scenes, a slice actually just points at a part of an array, and we can always select more from that array as long as we expand our selection towards the end of the array. Towards the beginning, that's not possible. And as a in-between step, we can actually again print the capacity with the cap function of main hobbies. And what we'll see when I do that, and I run this code, is that that capacity is free even though main hobbies only contains 2 elements. It's free because the array on which it's based actually has 1 extra element after that last element that we select here when we build that slice. And again, as I mentioned, extending the selection towards the end after we already have a slice is always possible. So we can reassign a value to main hobbies. Hence, I'm not creating a new variable here. I'm using an existing one. And I actually reassign based on my existing main hobbies slice. And we want to create a slice that gives us the second and last element. Now we are basing this new slice on the existing slice. The existing slice contains the first and second element. But because we have that link to the behind the scenes array and extending towards the end is always possible, we can also expand this slice to get the last element of the existing array. Now I'm not interested in the first element anymore, and therefore I'll start at index 1 to omit that first element, which was still part of that slice before, because we included the first element here when we originally created that slice. Now I want to go all the way to the end, and you could therefore think that you can just use this shortcut, but that would actually not work. If you save it like this and you then actually print main hobbies like that, if you give this code a try, you'll see that it actually just outputs cooking. So the last element, reading, is not included. The reason for this is that I'm building my new main hobbies slice on the existing slice. And the existing slice does not include the last element here because we only selected up to the last element. So only the first 2 elements. But I mentioned that expanding would be possible, and it is, but if you do expand a slice in the process of reslicing, then you explicitly need to specify the end index. If you leave it open like this, it will use the last value from the existing slice instead. If, on the other hand, I set this to free, as we did it here in line 12 as well, then we explicitly tell Go that we want to go to the underlying array and give us the element prior to index 3, which is this element which has index 2, and include that in the slice. Can be a bit of a gotcha, but this is how we can now extend our selection here. With this, if we now run this code, we got cooking and reading included. So the second and third element with that reslicing approach. Now in task number 5, we now want to leave that array we worked on thus far and instead create a brand new array that has one special trait. It should be dynamic. So we should be able to add new values to it. And therefore, here I'll add my solution for task number 5. And since it's an array that will contain a bunch of course goals, I will name it course goals. That's my variable name. And to create a dynamic array, we need to create a slice right from the start and let Go create the underlying array behind the scenes for us. The syntax for that is very similar to what we had up there. The only difference is that we don't specify a length ahead of time. The syntax we need here is that we still want to store strings because our goals are still pieces of text. And we still need the square brackets, but we don't give this a fixed length. Instead, we leave the square brackets empty and then add our curly braces to either create this as an empty slice at the beginning or to already store a couple of values. And since we should create at least 2 goals here, I'll start by setting 2 goals, which are learn Go and learn all the basics, something like that. These are my course goals. And that's already task number 5. Now we can also print this to see whether that worked, and hence print course goals. Go run this, and we see our course goals here. So that is working. In task number 6, we now want to change that dynamic array, and we want to set the second goal to a different one and also add a brand new third goal. Now let's start by setting that second goal. For this, in task number 6, I'll first of all access the second goal in course goals by its index with this square bracket notation, and the index here is 1 for the second goal, and we can change this to learn all the details. Something like that. Now we should also add a brand new third goal, and for this we can set course goals equal to the result of calling append. And append, as you learned, is a built-in function that operates on slices and allows us to add brand new values to slices. And here I want to append 2 course goals and append a brand new third goal, which is learn all the basics again, maybe. So we overrode learn all the basics with learn all the details, and then we add learn all the basics again as a third element. And now with that, if we print our course goals here after changing those goals, if we run that code, indeed we now see we have learn Go, then as a second goal, learn all the details, since we changed that here, and then as a brand new third goal, learn all the basics. And as explained, behind the scenes, Go did create a brand new array for us, basically ditch the old one, and bind this slice to that new array. That all happens behind the scenes for us. We don't have to worry about it. Now in task number 7, I now got a bonus task here that involves a struct, a product struct. And therefore, we first of all need to define this struct. So maybe here, right at the beginning of the file, I'll define my product struct as we learned it, give it an ID, which is maybe a string, a title, which might be a string, and then a price, which could be a float. And that's what we did before in the course already. Now we got the product struct. Now I want to create a dynamic array based on that struct. I want to create a dynamic list of products that contains at least 2 products right from the start. And then we want to add a third product to that existing list of products. That might sound overwhelming, but thankfully it's actually not difficult. Here for task number 7, I'll add my products variable, and here I want to contain a dynamic array. So we need a slice. So we need empty square brackets. Then the data type is not string or float or int, but it's product. And I mentioned this before already. You can create arrays that contain structs or even other arrays. You are not limited to the primitive value types of numbers and strings. Storing structs in arrays is absolutely fine, and that's what we'll do here. So this syntax now creates a slice, a dynamic array that contains products. And we can now initialize it with some product data by using the struct literal notation here to add brand new products with an ID of first product maybe, keeping the order defined here when I set up the struct. Alternatively, we can assign values by using the keys again, but here I'll just keep the order, add a comma, and add a first product as a name here, as a title, and then as a price $12.99. Since this can get a bit tricky to read here, we are also allowed to split this across multiple lines as long as we add a comma here at the end, and then even split the struct creation into multiple lines, and also add a comma here in line 44. And now if I reformat this, this is more readable. Now that's one product. We can now copy that and add a second one. So the second product, where I say a second product, and this has a price of $129.99. And that's now my products list, my dynamic list full of product struct instances. Of course, we could have also created those instances in variables ahead of time and then just added those variables into that list, or we do it like we do it here, all in one go, just in time. Either way is fine. And now, of course, we can again print our products like that. Now, when I save that, you'll note that I have some yellow squiggly lines here that tell me that I have some redundant type here. Now, it turns out, and that is something you can't know, but it turns out that when you create such struct literals inside of such an array, which already is defined to only contain these kinds of structs, you can omit the struct name here and just create the structs like that. Since Go already knows with certainty that this list will only contain products, because you clearly define it here. So then you don't need to repeat that type name here when you create the struct instances, even though you are allowed to do it. But it's redundant, so you can shorten the code to look like this. And now with that, we're creating that list of products, we're outputting it, and hence if I run that code, we see our product list down there. Now, since it's a slice here, and hence a dynamic array in the end, we can also solve this last part of the bonus task where we should add a brand new third product. And for this, we could create the product just in time or actually create a new variable that contains it. This is up to you, where I create my product with that struct literal notation. Now we need the struct name again because here it's not clear that we'll have a product struct in this variable because we're just creating the variable. And then here I'll give this an ID of third product as a name and give this a price of $15.99 maybe. Don't forget the comma at the end here to be allowed to structure it across multiple lines. And then we can append this new product and change our product's variable to be equal to the result of calling append on products, where we do append this new product now. And then if we want to, we can also again print this updated products array. With that, if you save everything and you run this, you now find that updated list down there, which contains that third product. And that's now also the bonus task solved. Maybe you also were able to come up with that. Maybe not with that shorter syntax here, but with the rest of this task. And if you did, great. If you didn't, no problem at all. We haven't seen this before, and now you did see it. you now also know that you can store structs in arrays and how that works in detail. Now, before we dive into maps, which is another interesting kind of data structure, there is one special syntax which I want to show you, which is especially interesting when you work with arrays and slices. Specifically also when you work with append. Append actually does not just take one value that is appended, instead you can append as many values as you want. So here we could also add a couple of other values here, as many as we want. There is no limit at all. So it's really up to you. Now that's good to know, but the key syntax that I want to show you is indirectly related to that. Sometimes you have an existing slice and you want to append another slice or array to it. Let's say here we have our discount prices, and that's a brand new list which I create here, a brand new slice, let's say, which I'll copy from up there, which contains totally different prices. Something like that. Now we might want to merge discount prices into this prices slice. Of course, here it's just an example, but it is highly realistic that you will have some applications that need to merge different lists. For example, existing users with a list of brand new users that signed up during the day. And you can use the append function to perform such merges as well. Now, for that, we can reassign prices and call append again. And now you could think that you just append discount prices like that. But if you try that, you get an error. And the reason for that is that you now try to add a slice, so a list of floats, in a place where a single float is allowed. Because prices is a list of floats, not a list of lists of floats. And discount prices is a list of floats. So adding the full list as one item into that existing list is not valid. Instead, we have to kind of pull out the existing items. And there is a special operator in Go which you can use for that. You can add 3 dots here after discount prices, exactly 3 dots, to instruct Go to go to this list and take out all the elements in that list, so these 3 prices, and add them as separated, comma separated elements to this append function, so to say. So that is an important syntax that allows you to pull out all the elements of a list and use them as separate elements in a place where separate elements are needed, like here for append. We can add as many values as we want, but they need to be separate elements. And that's what we create here with this operator. And therefore now, if we print our updated prices thereafter, after using this special operator, if we run our code file here, you see it's a long list of prices and it includes these prices here at the end. Now we had a very thorough look at arrays and slices. For the moment, we're done with that, and I will change the main package here in lists go to lists instead, so that go run dot no longer executes that, and I'm fine with those yellow squiggly lines here, because now I'll add a maps go file where we will have a look at another key data structure available in Go. And I'll turn this into my main package and give that main function. And therefore actually I'll move the lists go file into a lists folder so that we don't have a clash here with multiple top level files using different packages, which is something Go would not like. In a subfolder, using a different package is fine, as you learned before in the course. So now we get this maps go file, and in here I want to dive into maps. So what are maps in Go? A map is a different kind of data structure which you can also use to group data together. It's a bit like a struct, but different. Now let me show you how a map looks like before we then explore how it's different from a struct. let's say we want to store a bunch of website URLs here. So we have different companies, and those companies have websites. For this, we could add a websites variable. And of course, now we could create an array or a slice. So maybe a slice of websites where we have something like google.com and then also something like AWS.com for the Amazon Web Services. And then maybe a bunch of other URLs as well. This works, but saving those URLs like this could have a couple of disadvantages. For one, if someone looks at this code, or if we ever want to output this code somewhere, we just see the URLs. For some companies like google.com, it's clear to which company this URL belongs. But to understand that AWS belongs to the Amazon Web Services, it's important that you heard about that company and its abbreviation before, otherwise this doesn't tell you anything. So having an extra label here could make a lot of sense. Now, in addition to that, if you want to retrieve a URL, let's say you want to find Google's URL, you always need to memorize that Google is the first URL here so that you can retrieve it by index. Possible, but if you have a long list of URLs, this can get very cumbersome if you need to start counting those different URLs to find the right index. That's a problem a map can solve for us. We can create a map by using the special map keyword in Go, and then we have a special syntax here where we need to tell Go which kind of map it is. Because a map, like a struct, is a storage where you have values of a certain type and then keys that identify those values, so labels for those values. You have key value pairs, that's a map, just like a struct. I'll talk about the differences to a struct a little bit later. And since we have these two parts, key and value, we now need to define two parts when we tell Go how our map should look like. Because both the key and the value stored under a certain key can be of various value types. That's why we first of all add square brackets here, and between those square brackets, we let Go know which type of value will be used for our key. Very often that will be a string, but it could be anything. You could use some struct type there, so a pre-created or custom-built struct, or an integer, whichever key makes sense to you. Now here I'll start with a string. And then directly after the square brackets, without any blank or anything like that, you now set the value type. So the data type used for the values stored under certain keys. And here that will again be a string, because my URLs, which I want to store, will be strings. So in this case, both the keys and the values will be of type string, but that's not a must-have. You can have different types, and you can use all kinds of types for the key, and you can use all kinds of types for the value. Now, again, without a blank, you can add curly braces here. And this now finishes the creation of a map, though you can also initialize it with some default key value pairs, but you don't have to. You can also create an empty map, which is what this would do. But you can now also set some key value pairs, typically in a new line for better readability. And now here, since I made it clear that my keys will be strings, we need double quotes here to create such a key string. And that could be Google. And then you add a colon, just as you do it in structs, and you set the value for that key, which in this case could be https google.com. And then, separated by a comma, I can also add Amazon Web Services and then set my URL here, like that. And add a comma to make it clear that this is part of that overall map, and we have a line break thereafter. And this is now a map with two default key value pairs. Now we can, of course, as always, use the format package to print that map and see what that gives us if we print websites. By the way, as soon as you save, this code gets auto-formatted, and Go ensures that this is lined up such that it's a bit easier to read. Now, if you run that code, you will see that this map is being printed here in one line, but it is this map. Now we do have this map. Now we can, of course, also work with that map. For example, it would be very common that we want to extract one specific URL. And that's why we are using a map in the first place, because now we don't have to memorize its position and use the index, but instead we can extract a value by key. So here, if I want to print the URL of Amazon Web Services, then we access websites. And now again, just as with arrays and slices, we use square brackets. But now between those square brackets, we don't have the ID, but instead the key. So here now I can access Amazon Web Services. Of course, you need to make sure that you don't introduce a typo here, because otherwise, if I just type Amazon Web Service, for example, without the S at the end, we would target a totally different key, which simply doesn't exist here. So you must avoid such typos. But with that, again, if I run this, we can extract that URL here. And that's the advantage of maps. We can use specific labels, keys, to extract our values by such keys, and in some scenarios, that is simply easier to memorize than the position and the index of an element. Now, when you work with maps, you are also not stuck to the initial map. You can always add new key value pairs. So unlike with arrays, there is no difference between arrays and slices. A map is a map and it's always dynamic. You can always add new key value pairs. So if you want to add a new website, you just access websites, and then you access a key that doesn't exist yet. For example, here I could access LinkedIn, which is a key that's not part of the original map, and just assign some value here, like linkedin.com. And if we then print our website's map thereafter, if we do this, and we save all that code, and we run our code, then you see that here LinkedIn is part of that map. So adding new items is always possible and super easy. You just target a key that doesn't exist yet and add that value that you want to add. Of course, you can always overwrite a value by targeting an existing key and setting a new value for that key. Sometimes you also want to get rid of keys, and you can do that with the built-in delete function, which is built into Go, just like append was built in, and delete once a map and then the key that should be deleted. So here the map which I want to target is websites, and then the second parameter is the key which I want to delete, and let's say that's Google. So this first key here, and if we target that with this, and I then print websites thereafter, you will see that if you save everything and you then run this code here, this new map here only has Amazon Web Services and LinkedIn, but not Google, because we deleted Google. So adding items, deleting items, overwriting items, and reading items, that's all relatively straightforward with maps. Now, the big question that you might have is, why maps? We already have structs, which are already key value data storages. Well, there are two main, very important differences. The first important difference is that for maps, you can use anything as a key. Here we are using strings, but you could also create a map that uses integers or even some array or a struct as a key. So any value can be used as a key. And that gives you more flexibility, since you're not stuck to just using human readable text as keys, even though that is probably what you'll do very often. but you have more flexibility there. Another key difference is simply that maps solve a different problem. With structs, you have predefined data structures. For example, if I come back to that product struct, which we saw before, then we make it clear that we have an ID, a title, and a price. And that's then our product. Now, once we defined that struct, when we work with it in our code, we can't just add a new key value pair. Instead, this is set in stone, so to say. We also can't delete a key value pair from it. So these things which we can do with maps are not possible for structs. And that's not a disadvantage, instead a struct solves a different problem. It's great whenever you have clearly defined kinds of data that should have exactly this shape. Whenever you instead have a collection of values where you want to have custom labels to identify those values, a map is your choice instead. Like here for the URLs. This could be a super long collection of URLs for tons of companies, and we can expand it and shrink it just as we want with a map. It's a bit like an array. We have the same kinds of values, URLs, but we just don't want to have indexes, but instead custom labels. And that's why we use a map instead of an array. With a struct, we wouldn't have a good way of handling this. We could define a struct websites, but then there we would need to define in advance that we have Google, and that will hold a string value, and AWS, and that would hold a string value, and we wouldn't even be allowed to write Amazon Web Services like this. That would be an invalid struct key. So we would have a bunch of restrictions there, and we would simply use a feature to manage a collection of data that's not meant to be used for this purpose. You don't use structs to manage multiple values of the same kind with different keys, but instead you use structs to describe data entities in your programs. Something like a product or a user or a company or anything like that. And a map, on the other hand, is used if you have a collection of values which probably describe the same thing, though technically not necessarily, but then you can assign your own labels, your own keys, and use any kinds of values for those keys that make sense to you. So I hope I could make that clear what the difference between a struct and a map is, and why we have both, and why both solve different problems. In a nutshell, you can basically think of maps as arrays where you don't use indexes, but instead any labels of your choice. At this point in the course, we did already learn about a lot of important basics that you need to know when working with Go, but one super important block of concepts is missing, and that would be control structures. In this course section, we are going to dive into certain language features, certain syntax features that allow us to execute code conditionally and or repeatedly. And for that, we're first going to dive into that conditional code execution, why we might need that and what it does for us. We'll then also have a look at a related concept and see how we can handle expected errors in our code and what exactly expected errors could be. And last but absolutely not least, we are going to learn how we can repeat the same code snippet with tiny variations maybe as often as we need to repeat it, and of course also again why that feature exists and where this feature helps us. As so often for this course section, I got a brand new project, brand new Go file and a module that I created. And the Go file is basically empty. You know that from earlier course sections already. Now in this Go file, I want to fetch some user input. I want to get some user input, and to keep things simple and just focus on conditional code execution, we'll simply get the age of the user then, and then do or output different things based on the user's age. Because that is a typical use case. You have some user input, and depending on what the user provided, you might want to do different things in your code. And of course, that's just one example. You could also be getting data from a database, and you want to do different things based on which data you got. So very often when writing code, you want to execute different code based on some condition. And that's what we'll do here. So for that, to get started, let's first of all grab some user input. And of course, that works in the same way we did it multiple times before. We can create a new variable and use the buff.io package, which we of course then also have to import, to create a new reader. And to that reader, we pass OS and import that package as well, .standard in. And then we can use that reader to get some input, because on that reader struct, which it is, we have a method called readString. And that readString method reads until a certain delimiter, which in this case again is the line break here for me. And that then will give us that user input. So here I got the user input, and I got a second return value about which I don't care at the moment, though we will talk about that return value a little bit later in this section again, because in this section this will finally become important. Okay, so that gives us that user input. As before, we might want to clean that. So we might want to set user input equal to strings using the strings package, replace, and then replace our user input string, and that here should be colon =, of course, so that this works. So then replace our user input string and replace the line break text with an empty snippet, and then add -1 to do this for all occurrences of this line break. So now we got that clean user input, and let's say we expect the age of the user here. So I'll actually use the format package before we get that input, and of course therefore also import the format package up here. And on that format package, I'll use the print function to print something in the same line as the user will then be able to enter the input. And I'll say, please enter your age, white space. And therefore this user input will actually be the user's age. And hence we could rename this to user age input in all those places to make that a bit clearer. Now, since it's an age, we also might want to convert it. So I'll use that strconf package, which we also used before already, and import that as well. And on that strconf package, we can now use the parse int function, not parse float, because the age should be an integer number, and then pass user age input to parse int to try to extract an integer number from that user input. And therefore here I got my user age then, and this also returns two return values, and again I'll not care about the second one right now. In addition, user age input also wants more parameter values. It wants to know what our base integer is, so which number system you want to use in the end. And here we can use 0 for that base, which means the base will be inferred from the number that was entered. So if it is a regular decimal system number, it will be treated as such. And then we can also set a bit size here, which basically controls how big the number may be that's entered. And I'll use 64 here, though a smaller bit size would do as well. But with that, we now do parse that integer number provided by the user, and hence we got that user age value. And now it's time for the conditional code. Because now with that code prepared here, as a next step, I wanna print different messages in the command line based on the value the user entered. And that is a common scenario, as I mentioned before, that you have different pieces of code that should execute based on different user inputs or, in general, different pieces of data you got in your application. Let's start simple here. And let's say we want to output "Welcome to the club" if the user entered the age greater than 18. If that's what we want to do, then that's something we can achieve by writing a so-called if statement, which is a very important concept or very important syntax feature in Go. For that, you use the if keyword, which is built into Go, and then you write a so-called condition. In this case, we can refer to user age, and we can then use the greater than sign to compare this to another number. For example, 18. Of course, the greater than sign is not the only operator you can use here to do that, to make that comparison. Instead, you also got greater or equal, smaller, smaller or equal, or just equal, though important for equality, you use two equal signs, not just one. One equal sign is used for assigning values to variables. For comparisons, where you want to compare one value to another, you use two equal signs, like that. You can also add an exclamation mark in front of an equal sign to check for something to not be equal. So if user age should not be equal to something else, then you could check it like this. But here I want to check that user age is greater than 18, and hence we can write it like that. Next, you add curly braces, opening and closing, and between those curly braces, you add your body for this if statement. So the code that should execute if this condition is met, and only then. So whatever you put between those curly braces will only execute if this condition here is met, in no other scenarios. So here we can again use the format package and now print a new line where we maybe say "Welcome to the club," because that's the message which I did want to output if the user age is greater than 18. If the user age is not greater than 18, then nothing will be output. The main function will just finish and not show us anything, since we have no other code in this function. And here actually we could make an argument for checking for a greater than or equal, since you should be welcome to the club if you are at least 18. Because with just greater than, you would have to be at least 19 to meet this condition. So let's convert this to greater than or equal. But of course, ultimately, it's up to you which kind of logic you want to have here and which kind of check you want to perform here. Now with that code adjusted like this, we can save all that code and then of course again execute it to run our module, and then we can enter our age. And if I enter 15 here, which clearly is smaller than 18, we get no output at all. Because as mentioned, there is no code that would execute for that scenario. If I run this again and I enter 32 here, then I get "Welcome to the club" as expected. So then the code inside of that if statement executed successfully. And that's in a nutshell how if statements work. But there is a bit more to it that you should be aware of. Now let's first of all understand which code executes when. As I mentioned, this code inside the if statement only executes if this condition is met. But this does not mean that other code would not execute if the condition is not met. If I add another print message, println message here, after the if statement, where I say goodbye, then this code here will always execute, no matter if you make it into this if statement or not. It's really only the code inside the if statement that is conditional. Code after the if statement will still execute even if you don't make it into this condition. So the if statement and the result of this comparison does not matter when it comes to the overall function execution. That function execution will continue no matter if you make it in there or not. So therefore here, just to quickly show this, with this goodbye message added, if we run this again, even if I do enter 15, we get goodbye in the end. And of course, we also still get that if I enter 32. So that's one important thing to note. Another very important thing to note about if statements is that this comparison here actually produces a so-called Boolean value. And you might remember that from way earlier in the course. Here, on this slide, on the top right, there is this bool value, this yes-no value. I mentioned it pretty early in the course already, but we haven't needed it up to this point. Because Boolean values are mostly useful if you do work with if statements, because they answer a yes-no question. They only contain true or false. And that's exactly what you need for an if statement. If true, then execute some code. If false, don't execute it. And therefore, a check like this, so the check you see here, user age greater or equal than 18, actually returns a Boolean value. This is an operation just as 2 plus 2 is an operation. 2 plus 2 yields a number, 4. User age greater than or equal than 18 yields a Boolean. And therefore, you could also create a new variable, is old enough, where you store the result of that comparison, like that. And then here, instead of performing this comparison just in time, so to say, we could refer to is old enough. Because is old enough, as you see here, holds a Boolean, and in an if statement, you always need such a Boolean value. You could also just write if true, and that would be valid, but it's of course not useful. Because now this code will always execute because true will always be true. That's why you instead use the result of some comparison, like we now have it stored in is old enough. Now we still have a Boolean in there, but it will not always be true. Instead, it depends on this comparison. Now it's up to you whether you want to perform the comparison first and then store it in some variable and then only use the variable in your if statement, or if you want to perform the comparison just in time, so to say. You typically do it just in time, but storing it in a variable can be very useful if you need the same comparison in different places of your code, because you then don't need to retype that code over and over again. Instead, you can then just use that existing variable in all the places where you are interested in the result of this check. It's as always in programming, you want to avoid duplication, and therefore if you have this exact same check in different parts of your code, storing the result in a variable and using that variable instead could be worth a thought, but otherwise performing a check just in time is probably more common, since you then don't need to look at other parts of the code to understand what this if condition actually checks. And therefore here I'll comment this out so that we still have it for reference, but I'll stick to this just-in-time check here. Now, very often when working with if statements, you don't just have code that should be executed when a certain condition is met, but you also have code that should explicitly be executed if the condition is not met. Now, adding such code after the if statement will not do the trick, because this code is always executed as you learned, no matter if this condition was met or not. So if you have code that should explicitly only be executed if this condition is not met, there also is an addition to the if statement that's useful, and it's an addition which you also find in basically all programming languages. You can add the else keyword here, and then again add a pair of opening and closing curly braces thereafter. The code between those curly braces will now only execute if this condition here is not met. So here we could then output another message where we maybe say, sorry, you're not old enough. Something like that. And now with this, if we save this code and we run it, Then if I enter a value smaller than 18, we see this alternative message. And of course, if I enter a value greater than 18, then we get that other message. So now we also have a way of running some code explicitly if that first condition is not met. Now, it's also not uncommon that you might have multiple conditions that you want to check and you want to execute different pieces of code based on which condition was met. At the moment, we check if the user is at least 18 years old, and we also have this else condition. But maybe we want to check if the user is at least 30 years old, and then output a specific message, like you're eligible for our senior jobs, whatever, something like that. And we still want to have that else message, but only if the user is not older than 18. But here we're checking for 30. So now we might want to add another branch where we check if the user is at least 18, even if he or she is not older than 30. Because if we didn't make it in there, that doesn't automatically mean that the user is not at least 18. For such scenarios, we can add a else if branch to our if statement. Again, with curly braces thereafter. However, if you use else if, you now also need to add a brand new condition. And here we could check if user age is at least 18. So now, the way to read this and the way Go will execute this is that Go first of all checks if this condition is met. Is the user age greater or equal than 30? If that's the case, this code here will execute and the rest of this if block will be ignored. No other code from that if statement will execute. This code down there, of course, will. Now, if this first condition is not met, Go will go ahead to the next else if branch in this case and then check this condition. If this condition should be met, the code in there, which we'll add soon, will be executed and the else statement will be ignored. The code down there will always be executed. If this condition here should also not be met, then Go will go ahead to the next else if statement, if there is one, because you can add multiple else if statements to the same if block, or to the else statement otherwise, if it exists, and then execute that code. So that's how that will work, and therefore here in this else if block, I'll also print a new line, and here I'll say, welcome to the club. So what I had before as well. But now we have these different branches with different conditions. And hence, if that code gets saved and we execute it, if I enter 15, I still get that you're not old enough message. But if I execute this again and I enter 25, I get welcome to the club. So this else if message here. But if I enter a value that's at least 30, then I get you're eligible for our senior jobs. So that message from the main if check. And that's how you gain a lot of flexibility when it comes to working with if statements and executing different pieces of code based on which condition is met. Now there is even more to if statements. At the moment we know that we got if, else if, and else, and that's super important. But also inside of a single condition, you can combine multiple conditions. Because maybe we want to output this message if the age is at least 30, but not higher than 50, let's say. For such cases, we can combine this first comparison with another comparison with the double ampersand operator, the so-called AND operator. After this AND operator, we can add another condition. For example, user age smaller than 50. Now, this overall condition will return a Boolean, and hence this overall expression here could be saved in a variable, as we did it here. And only if both conditions are met, so this one and this one, will make it into this if statement here. If at least one of the two conditions is not met, we'll not make it in there, and Go will move on to the next branches. Now, since I added this check, checking for the age being smaller than 50, I actually want to add another else if branch where I handle the case that the user is older than 50. So here I can now check if user age is greater or equal than 50, greater or equal, because here I'm checking for just smaller than 50, so we can't have a clash here. And then I could output some other message like the best age, whatever. You can of course fine tune this however you want. Now you can also not just combine checks with the AND operator, but you also have the OR operator. For that, let's say, for some reason, we want to print this message if the user is older than 30 but younger than 50, or if the user is older than 60, for whatever reason. In that case, you can add the double pipe symbol operator, the OR operator, and then check if user age is greater or equal than 60, for example. Now this code here will execute if this condition is met or this condition is met. And in terms of priority, how this will be evaluated, Go will always first check the conditions that are combined with AND. And then if this returns true, it will also have a look at the other conditions that are combined with OR. Now the OR operator differs from the AND operator such that for the AND operator, both sides need to be true. For the OR operator, it's enough if one of the two sides is true. So even if that's false, we'll still execute this code if this condition here is true. And therefore now if we save that and we run our code again, if I enter 39, I get this, you're eligible for our senior jobs. If I run 55, I don't get it. I get the best age then. But if I enter 62, I again get, you're eligible for our senior jobs. You can, by the way, also use parentheses to group checks together to clearly define which kind of combined checks should be performed first, just so that you can be sure that Go is really performing the checks in the order you want it to perform those checks. And with that, you got lots of ways of customizing your if checks and therefore lots of ways of executing code conditionally. And as it turns out, being able to check for different values in your running programs to then execute different pieces of code is a very common requirement, and you will need if statements in almost every serious program you're going to write as a Go developer. Now that we explored if statements, I want to talk about error handling. And for that, let me first of all clarify what I mean when I say error handling. Of course, you can have errors in your code, like a mistyped variable, that you should avoid at the point of time you're writing your code. Your IDE helps you with that and shows such errors. And even if you don't spot it there, if you run your program, you will get an error when you try to do so. So these are errors which you can and of course have to avoid as a developer. Simple typos and bugs like that. But there also are errors which you can't avoid as a developer. And we got a great example here in this example. We're fetching some user input here, and we are then parsing this as an integer. Now, of course, as a developer, we can't guarantee that the user will really enter a value that can be parsed as an integer. For example, here, if I execute this, instead of entering my age, I could enter max, which is not a number, and hence parsing this fails, and hence the program actually doesn't crash, but it also does maybe not behave correctly. You might remember that earlier when we worked on the body mass index application, when the user did not enter correct numbers, we got that not a number special type there. So the application there didn't show the correct result. And here it's just showing that else case message, but that is actually maybe also not what we want to do in such a case. If an invalid input is entered, like we have it here, we instead might want to show an error message to the user telling the user that the input was wrong. And these are kinds of errors in your code where the program then does not behave correctly that you can't avoid in advance as a developer because you can't control what your users will enter. And of course, that's just one example. You also could have an application that sends HTTP requests to some server, and maybe that server is offline and therefore you don't get back a response. That would be another kind of error that you can't prevent as a developer. But you can expect such kind of errors. You can consider things that can possibly go wrong and then write code that should handle those cases when things go wrong. So for example here, when we're not able to parse that user input correctly because we haven't received a valid number, then we could handle that and show an error message to the user telling the user that the input was wrong, possibly allowing the user to enter the input again if we want to. And that's where this second return value comes into play. You might maybe know other programming languages where you have built-in error support and you can raise or throw errors if things go wrong. In JavaScript or Python, that is how you can, for example, handle errors. In Go, there is no such mechanism. You don't throw errors, you don't raise errors. Instead, in Go, you utilize the feature that functions can return multiple values to return error values as second or third or whatever return values that tell the caller of the function whether that function call succeeded or if something went wrong. And if we hover over parseInt, we can actually see that. Here we got a description of the return values, and we see that the first value is the integer. The second return value actually is an error thing. And if we read that description here, for example, we also see that parseInt may return errors that even tell you what went wrong. So here, instead of ignoring this second argument, we could give it a name of error or error. It's up to you, because you are still creating your own variable here. But error or error are typical names which are often chosen, and I'll go for error. Now, what is this error thing? It's of type error. But what is this error thing? Well, let's maybe just print it to the command line so that we can look inside of it. So here I'll print error. Now with that change made, let's start by running this again, and let's first of all enter a valid age, like 19. If we do that, we see that we get this nil output here. Nil, written like this, is actually a built-in value in Go that basically means there is no value. And it's used as a null value for certain value types. For example, a pointer that you created as a variable, but that hasn't yet received the address of a concrete value, would have a nil value. So it basically means there is nothing there. And that makes sense because we got no error here, because I did enter a correct number. But now let's see what happens if I do enter something that can't be converted to a number, like my name. If I enter that, then you see I get this error description here. And that's good to know. We get nil if everything worked, and we get some description otherwise. That means that if we want to show our own error message, that we can add another if check and check if error is not equal to nil. Remember, I mentioned that there is this not equal operator. If it's not equal to nil, then we know that there is an error. And in this case, we could show an error message with print line, where we say invalid input. Now, depending on our program, we could now prompt the user for input again, or we just stop the program, which we can do by simply calling return here. We are in the main function, and whenever you return inside a function, even if you don't return a concrete value, the function execution will stop. That is what the return keyword does. It's typically used to return a value, but you can always use it to stop the function execution. Because whenever you use return, the function execution will stop thereafter. Now, since return is used inside of this if check here, the function execution, and therefore our overall program here, will only stop if we make it into this if check. So only if we have an error. If error is nil, so if we have no error, we won't make it in there, and hence the function execution will continue and will make it down there. And that is how you typically handle errors in Go. You use this special error return value, and if that's not nil, you know you have an error, and then you can handle it the way you want. And therefore, if I now save this again, if we run this again, if we enter something valid, everything works. But if we instead enter something invalid, I get my error message and no other output because the function execution stopped. Now here we see how we can handle errors that are provided to us by some other function. But of course we can also write our own functions that return errors if something goes wrong. And to show this to you, let's outsource this code here into a custom function, actually including the reader. So let's grab that code here, cut it from main, and add a brand new function which I'll name getUserAge. And in there, I'll perform all that reading stuff here. And then ultimately, in the end, I want to return the age. So I want to return an integer here and return user age, this variable. And actually here, this is technically of type int64, which is a bit more specific than just int. So to ensure that everything works, we need to wrap this with the built-in int conversion function, which will, behind the scenes, make sure that the integer we're parsing here is of type int. Now we got that error here, and we could also bring down our error handling code. But maybe we want to keep error handling in the main function for some reason. Well, then we could just return this error variable, which we get here as well, as a second return value, like that. We could, of course, also create our own error variable and set that to nil if everything is fine, and set it to some other value if we want to create our own error message or whatever. But in its simplest form, we can simply forward this error return value which we get from parseInt. Now we just need to make sure that we adjust this return value of our function, since it now doesn't return just one value but two values. And hence we return multiple values and we add the types in parentheses. And the second value type is actually error, which is another built-in type, another type built into Go that is specifically used for such errors. If you need to create your own error, you can always use the errors package for that. And in there you find a new function where you can enter some error message, for example, invalid input, and that will then give you a value of that error type. So then you could store that in your own variable and return that variable instead. Now you would have your own error. Here I'm just not doing that because I already got such an error here through that error return value from parseInt, but you could easily create your own errors as well if that is what you need to do. And now with that custom function built, which also potentially returns an error, we can call getUserAge here in main, and then we get back the user age, but also this error here. And hence that's how we should handle the return values of that function then. And we can now still handle our potential error here in the main function. Now that we got if statements and error handling out of the way, it's time to move on to repeated code, which we'll implement with a feature called loops. Now, for that, I renamed the control structures Go file into conditionals.go and moved it into a conditionals folder, gave it the conditionals package, and I added the brand new, pretty empty, pretty basic loops Go file in which will work. Now, the great thing is that I got a little demo example project in mind for diving into loops and diving into repeated code, and we can prepare this project together because whilst preparing it, we can practice what we learned over the last course lectures, so that should be a good thing. Because I have a program in mind, a simple demo program, where we can practice different kinds of repeated code, where we will prompt the user for a choice. Our program will be able to perform a couple of different operations, add up numbers, build the factorial of numbers, and so on. And therefore, we want to prompt the user for a choice and then execute different kinds of code based on the choice that was made. And then as a next step, we'll implement loops to perform the actual operations our program should perform. Now, to get started, I will first of all define a global reader variable, a global because I want to use it in different parts of this program, in different functions. And we'll use the buff.io package for that, import it, and create a new reader as we did it before already. And then, of course, use the OS package and reach out to standard in. Now, in the main package, I then want to prompt the user for some input to make a choice about which program or which part of this program should be executed. And for that, I'll add a helper function, get user choice could be the function name, where I first of all will use the format package, which of course therefore also needs to be imported, where we then output some message like, please make your choice. And then I'll first of all present the user with a couple of options. So I'll print another message in a complete line where I say the first choice, for which the user then should press the 1 key on his or her keyboard, is to add up all the numbers up to number x. And the user should be able to choose that number x then, if he or she makes that choice, and then we'll build the sum from 0 up to that number. Now I'll then copy that because my second option, which I want to present to the user, is to build the factorial up to number x, so that if we enter 5, we would return the result of 5 times 4 times 3 times 2 times 1. The third mini program that I want to implement in this program, and therefore the third choice offered to the user, is to sum up manually entered numbers, so that once the user chooses this option, we ask for more and more numbers, and we build the sum of those numbers until the user stops that, until the user does not enter any numbers anymore. And we're going to write the logic for all these different options over this course section, of course. Here we're just getting started. And the fourth option which I want to present is that we sum up a list of entered numbers. So here we don't ask for numbers again and again and again. Instead, we ask for a list of numbers separated by a white space, for example, once, and then we'll build the sum of those numbers. And these 4 choices will then later allow me to show you 4 different ways of looping through various values, and you'll see why we need loops to begin with. Now here at the moment we are of course just printing something. Now we want to use the reader to read the user input. So to read a string, and as always, read until that line break character is detected. Now read string returns us that user input, but it actually also returns a second value, which we always omitted up to this point. And that second value, as it turns out, is actually also such an error value, because here already something could go wrong. And hence, we should now also accept this properly and not ignore it anymore, because in general, you should never ignore potential errors, but always handle them. But then here in getUserChoice, I actually won't handle it yet. Instead, I just want to return it along with the actual user input if we have no error, and then handle a potential error in the main function later. Therefore, the only thing I want to do here at the moment is I want to check if error is not equal to nil. But if it is not nil, so if we have an error, I don't want to show an error message yet. Instead, I'll just immediately return so that other code, which I'll add soon, won't execute. And I'll return an empty string because we don't have a user input because something went wrong, and I'll return that error, which is not nil. So I return these two values. I return these two values because I'll also return two values if everything works. And therefore, my getUserChoice function will return two values. The first value will be a string, the second value will be of type error, though of course that could be nil if we have no error, just as I explained it over the last lectures. Now if we have no error, then we get some user input, and then I just want to clean it. I want to get rid of that line break character. So then here in that case, I will use the strings package, which we also saw before already, and use that replace function to replace user input and replace all the line breaks in there with nothing and replace that for all occurrences. And then I got my cleaned user input like that. Now, once we cleaned user input, I want to make sure that it's either 1, 2, 3, or 4, because if it's anything else, then it's also invalid, and then I want to produce and return my own error. Because then it might not be a technical error, but I know that it will be some invalid input for this application which we are writing. Because only the numbers 1, 2, 3, and 4 entered just as such as plain numbers are acceptable for this application. And we also learned how we can implement that. Here at the bottom, once we got the cleaned user input, I want to check if user input is actually equal to 1 as a string though, not as a number, because we haven't parsed it as a number yet. We are still operating on a string here. And I want to check if user input is equal to 1, or if user input is equal to 2, which is also acceptable, or if user input is equal to 3, which is also okay, or if user input is equal to 4, which is the last value I accept. If either of that's the case, and we can split this across multiple lines, by the way, to improve readability, like that. If either of that is the case, then I know I have a valid user input, and then I want to return user input and nil as an error value, because then I have no error. If we had an error here before, we already returned, so at this point I know that I have no error if I make it in here. However, in the else case, that we have neither 1, 2, 3, or 4 as a value for a user input, in that case I'll return an empty string, because then I have no valid user input in the end, and I want to return an error object. And here I'll build my own error with help of the errors package, which is built into Go, which we need to import though. And on that errors package, we got that new function where we can now add our own error text, invalid input for example, and now we'll return this error if we have an input we can't handle. So now with that, we got our getUserChoice function. In main, I can now call getUserChoice, and I'll get back the selected choice, or however you want to name it, and the potential error we might have gotten. Now, of course, we should handle that error here. And if the error is not nil, so if we have an error, then here I again want to format and print something. I want to say invalid choice exiting, because we are exiting the program now, because I'll then execute return, which, as you learned, ends the function execution. Now, if we make it past this if check, we know that we have no error and we can now work with selected choice. And therefore here, as a last step for this preparation here, we can now check which choice was made and perform different operations for the choice being equal to 1, 2, and so on. So I'll check if selected choice is 1, and if that's the case, I'll execute a certain piece of code. Else if selected choice is 2, and we're always operating on strings still, that's important, not numbers. So if it's 2, I'll execute some piece of code. Else if selected choice is equal to 3, we'll execute a certain piece of code. And else we know it has to be 4, it can't be anything else, because if it would be anything else, we would have created an error here at the bottom. So it can't be anything else. So we know else here means that it's 4. And in that case, I want to execute the code for this fourth option here. And now I'll just add a couple of functions here into which we'll later add the code for those different operations. And the first function will be the calculate sum up to number function. Quite long name, but I want to be clear about what this function does, and we'll add the concrete function code later. The second function will be the calculate factorial function for option number 2. Then we'll have the calculate sum manually function, and we have the calculate list sum function. And now we can just call these functions here. The calculate sum up to number function here in the case that we chose 1, because that is our first program that we want to execute then, that we add all the numbers up to a certain number. So hence we execute calculate sum up to number in that one case. In the second case, we want to build the factorial. So I'll call calculate factorial. In the third scenario, I will actually execute calculate sum manually. And in the fourth scenario, I will then calculate my list sum. And that's now the starting code for the loops feature into which I want to dive. I found it quite interesting to write this together since it allows us to practice what we learned. And therefore, I think it is interesting to write this together before we do now explore that loops feature. And here I'm just getting some yellow squiggly lines that I should remove that punctuation. And that this should be capitalized, invalid input, like this. That's just some general pattern you want to follow. So of course we want to do that here as well, so that we have more like an error code here instead of a concrete error message, which makes sense since we do write our own error message here anyways. And we could then just use this error code to show different messages based on different codes. But that's not something we gotta do here. So therefore, let's now move on and explore loops. Let's get started with loops, which allow us to repeat code. And let's understand why we might want to repeat code in the first place. For this, let's start in that calculate sum up to number scenario. Here, the goal is to let the user enter some number, let's say 7, and then we want to add up all the numbers leading up to that number. And if you think about that problem, that already implies that we might need to repeat some code. We want to add a number to a number and to yet another number. And at the point of time we are writing this code, we of course don't know which value the user will enter. That's why we need to repeat code until we reached the number the user entered. That's the idea. And that's what we'll implement here. So in calculate sum up to number, I first of all want to get the number the user chose. And for that, I'll again use that reader and read a string. Read a string here. Again, using that line break character here as a delimiter. And here we got the input number and potentially an error. And of course, we quickly want to handle that error. If it's not nil, we know we got an error. And then I want to print a little message here, invalid input, for example, and return. So stop the function execution since we now can't continue. But if we make it past that, I want to clean that input and now transform it into a number. And here I'll just focus on integer numbers. So I'll transform it into an integer number. And we, of course, did learn how that worked. For this, we can again use the strings package and the replace function. And then use the input number, look for the line break character, replace it with nothing for all occurrences. And that will give us the cleaned input number. And then we can convert it to a number. And of course, that's an operation which we will probably repeat a couple of times, so we might want to outsource this into another utility function. But let me first of all finish it here. Let's use the strconf package to parse an integer from the input number. 0 is the second parameter value to infer the number system from the entered number. And then here I'll use 64 as a bit size, and that will give me the chosen number here in the end. And actually, we might also get an error here, so we should also handle that. Copy this here, add that, and then here maybe say invalid number input or anything like that. And now with that, we know that after this if check, we got the chosen number as a valid number. Now again, that is an operation which we probably are going to repeat a couple of times, and therefore I'll grab all that code here and actually cut it from calculate sum up to number, and instead add a little utility function here, get input number, into which I'll paste that code. And that is a function that should actually return an integer or an error. And if we got an error in here, in this function, I want to return, let's say, 0 as an integer, but more importantly, I return the error that I got. The same down there, return 0 and the error. But if we made it past all the if checks, then we know that we have a valid number. So then I'll return chosen number, however, converted to an integer by calling that int conversion function on it. And I'll return nil as an error value because we then don't have an error. And now with that, with this get input number function, we got a little utility function which we can call in our overall application whenever we need a cleaned and converted number from the user input. And therefore, here in calculate sum up to number, I'll now call get input number, and I'll get back the chosen number, and then potentially an error, like this. And now we just need to check if error is not nil, which means we have an error, in which case I wanna print invalid number input and return. And otherwise, after this if check, we can continue with a cleaned and converted number. As a side note, inside of get input number, I of course now don't want to show those error messages. I don't want to print those error messages. I just want to return the error if we have one, so that we actually do handle it in the calling function, in calculate sum up to number in this case. And now we got the chosen number, which we can now use in a loop. Now, why do we need a loop? Well, again, chosen number is a number chosen by the user, and we now want to add up all the numbers leading up to that number. And that's where a loop can help us. So how does a loop help us here? Why do we need a loop? Because we want to repeat a certain operation. We want to add numbers up to this number, And that means that we need to perform multiple additions, so the same operation multiple times. That's where a loop can help us, and in Go, like in many other programming languages, we can create such a loop by using the for keyword. That creates a so-called for loop. Now, the for loop can take many different shapes and forms, and we'll see all those different ways of using for in this course section. But the most straightforward and standard way of using for is to use it with a helper variable that exists only for this loop, that changes after every iteration. Typically, that helper variable is a number, which then, for example, is incremented after every iteration. And we then have a condition that keeps the loop running as long as it's met. So let me show you how that works. We start by initializing that helper variable. It's a brand new variable created with the colon equals an operator, and it's created in the same line as the for keyword, and it will only be available inside of the for loop, therefore. And we use I as a variable name typically because that stands for iteration, but technically you can use any variable name you want, including longer names. But I is the convention. Then we add a semicolon. One of the rare cases where we manually add a semicolon in Go, because we add another piece of code in the same line still. And the semicolon tells Go that a new code expression starts even though it's in the same line. This next part is the actual condition that keeps the loop running. As long as the condition is met, the loop keeps on running. And here we use a condition just as we did it in if statements. We can, for example, check that I is smaller than 5. So as long as I is smaller than 5, the code, which we'll soon write inside of the loop, will keep on executing. Of course, since I is 0, this condition will always be met. And that's why we have a third part here, also separated by a semicolon. We now define how I, this helper variable, should change after every loop iteration. For example, we could say that 1 should be added to it, or 2, or we multiply it with 2, whatever you want to do. Now here I'll simply add 1 to it. That's the most common form of changing I in a loop. And there is a shortcut for this. You can write it like that. That's the equivalent to setting I equal to I plus 1. It's simply shorter and it increments I by 1. Then we add our curly braces, and now here we can write the code that should be repeated. In this case, that should be repeated 5 times. So here we can then, for example, simply print I, and to test this, I'll also print chosen number outside of the loop so that we don't get any complaints because this variable is not being used. And with that, we have our first dummy loop in place. Now let's give this a try. We can run this program, and we are then prompted to make a choice. And here we want to choose 1 because that's the only function where we actually wrote some logic up to this point, our dummy loop logic. So I'll enter 1 and hit enter. And then we enter any number of our choice, for example, 1 again, doesn't matter. And now we see this. Now we see that this seems to work. Here we see the output from our loop. 0 to 4, 5 is not a value we see because we only keep on looping as long as I is smaller than 5. If it's equal to 5, we'll quit this loop execution. And that's why we see this output, and that's how a loop generally works now. Now there's one little change, one little adjustment I want to make, not directly related to my loop, but of course when I'm getting a new input number here, I want to give the user a little bit more information and hence actually print a little message here where I say, please enter your number. And now that's not a number for making a choice, but the number up to which we'll build a sum later. So just to add more context. And I'll also go to get user input. And here, before prompting the user for input, I also want to say, please make your choice. Like that. Now I added a little bit more information by outputting more information here. And now we are ready to work on that loop and switch from that dummy loop to a loop that actually does something useful for us. Now, how could we adjust that loop to do something useful for us? Well, instead of looping as long as we are smaller than 5, I instead want to keep on looping as long as I is smaller than chosen number. So I'll replace 5 with chosen number. Now, if the user chooses 10, we will keep on looping as long as I is smaller than 10. Now, since I want to add up all the numbers, I will actually start at 1, because adding 0 won't have any effect. And I'll keep on looping as long as we are smaller or equal, because I want to include the number chosen by the user. I don't want to exclude it. Then I'll add a sum helper variable, which starts at 0. And I want to change that sum with every loop iteration now. So sum is then equal to the old sum plus I. And I will change with every iteration because we are changing it here. And then once the loop is done, once we reach the next line of code thereafter, I can therefore print my result. I can say result and then output that value which is stored in sum. Something like that. And now with that, we're using what we learned in the last lecture to solve this concrete problem and to add this specific feature to our demo app. Now we can build the sum up to a certain number chosen by the user by simply going through all the numbers up to that number, by looping through all the numbers up to that number, and then by repeating the same operation with different numbers for all those numbers. And then we output the result in the end. And hence now with that, if we run this again, and I choose 1 here, and actually let me quit this, looks like I have a tiny error here. Please make your choice. That's being prompted in the wrong place. Don't want to do that here in get input number. I want to do it here in get user choice. Here, right before the user makes a choice. So let's move that here. And now, sorry about that, let's save all of that again and run this again. Now we make our choice, 1 in this case, then we enter our number, for example 5, and as a result, I get 15 here. And that should be correct, because 5 plus 4 plus 3 plus 2 plus 1, that is 15 if you add all of that up. So that's working, and that's a great example for why this loop feature exists and why we might want to use it. Now that's the most basic form of a for loop. Now I want you to apply what we learned and also implement this calculate factorial function. And do just that, calculate the factorial. So that, just in case you're not sure, if the user enters 5, you should calculate 5 times 4 times 3 times 2 times 1, and then output the result of that. That's what you should implement now, again by using a for loop. And I'll give you a couple of seconds to pause the video and try this on your own. Thereafter, we'll implement this together. So, did you succeed? Let's now implement this together. For this, we can actually copy large parts of the calculate sum up to number code. I'll actually copy everything and I'll then adjust the code where needed. Of course, we might find a way of refactoring this a bit to outsource some shared code into an extra function that's then reused. But I'll just copy the code for now and add it here to calculate factorial. Now, indeed, the user there still should start by entering a number, the number up to which we want to build the factorial. We want to get that input number so we can use that function again. We want to check for errors and show our feedback if there is an error. And then here, in the end, don't need to output chosen number anymore. We want to build the factorial with help of such a loop. And that's now fairly easy to do. We're not building the sum anymore, but instead the factorial, if you want to call it like that, and use that variable name here and here. But we still need a loop where we loop through all the numbers leading up to the chosen number. But this time, we want to multiply those numbers with each other instead of adding them together. So here we simply use the existing result that we got and multiply that with I. Though there is one important adjustment, we need to start at 1, not at 0, otherwise we'll in the end multiply everything with 0 and therefore get 0 as a result. So we need to start at 1 here as a starting value for factorial. And then when we loop through all the numbers in the first iteration, we'll have 1 times 1, so we get 1 as a result. But in the next iteration, we'll have 1 times 2, so we get 2. In the iteration thereafter, I will be 3, and the previous result was 2, so we have 2 times 3, and so on. So that should do the trick. Hence, we need to make sure that calculate factorial is being called here if the choice is 2, and that is the case. And therefore, we should be fine. If we now save everything, and we again run this code, now we can choose the second option and enter our number, maybe again 5, and I get 120. And 120 is correct because that is 5 times 4, which is 20, times 3, which is 60, times 2, which is 120, times 1, which is still 120. So that is working. And we now again implemented this with help of the for loop, which, as you can tell, is therefore quite versatile and helpful. And of course, that's just one example where a for loop can help us. In practice, as you write more and more programs, you'll encounter more and more scenarios where a for loop like that can help you. But there also are scenarios where this kind of for loop is not the best choice. And we'll have a look at such a scenario in the next lecture. Now I want to move on with our dummy application. And the next case that we want to handle is that the user entered 3. And then we want to calculate a sum manually. We want to keep on prompting the user for new numbers, and then we want to add up all those numbers that are being provided by the user. Because choice number 3 is that we want to sum up manually entered numbers. Now, for that, we got our calculate sum manually function, which we call if the user chooses 3. But here, the for loop, as we learned it before, won't help us. Because now we don't have a target number that we want to reach by iterating, but instead we want to keep on iterating as long as the user enters numbers. That's a different scenario. Still, the for keyword and a for loop can help us. And that is a difference compared to other programming languages. In a lot of other languages, like for example JavaScript, you have while loops, which can be helpful for scenarios like that, where you want to keep on looping as long as a certain condition is met. But here in Go, we don't have a while loop. Instead, we simply have a different way of using the for loop, which is also supported. Because if you think about it, the regular for loop, which we used before, also keeps on looping as long as a certain condition is met. But in addition, we also have that helper variable, which changes with every iteration. It's all built into the for loop. Go also supports a variation of this for loop, where we don't have this helper variable, but where we instead just have a condition. And that's something which will help us here. Here, we could add a new variable. For example, is entering values or is entering numbers, which we set to true initially. So it's a brand new variable which I set to true, so to the Boolean value true. And that's not something we did before in the course. Before we stored the result of a comparison in a variable, but we didn't set the variable itself to true directly like this. But now it is something we can do, because now we can keep on looping as long as this is true, and then stop looping once this is false. And therefore we'll have to write some code where we later set this to false. But here we can now also write the for loop as for and then is entering numbers, and then opening and closing curly braces. Alternatively, we could also have any kind of check here, which we also can have in a if statement. If 5 is smaller than 10, or if variable a is smaller than variable b. That's all possible. You can also use the and or operators, but you can also just point at a variable that contains a Boolean value. Because that's important. In the end here, you need a Boolean value, no matter how you derive it. And here we just start with true. Now, as long as this is true, the code in here will be executing. And therefore, out of the box, if we write code like this, we write an infinite loop, which never finishes. And that's rarely what you want, because that will cause your program to never finish. But it is what we want if we then also make sure that inside of that loop, under some condition, we set this to false. Now I'm writing it like this because I want to keep on looping to keep on prompting the user for new numbers until the user does not enter a valid number anymore. Because then we can add another variable, the sum, let's say, because ultimately we want to calculate a sum that starts at 0. And then here inside of the loop, I want to get my input number. So I want to ask the user for a number, just as we do it in calculate factorial and calculate sum up to number. I want to ask the user for a number, and I want to get that chosen number and also that error that we potentially get. And now I just want to use that chosen number and add that to my sum, so that we don't just ask the user for a number once, but we keep on asking as long as we are looping. And then here we can set sum equal to sum plus chosen number. Now we also need our exit condition, where we then set is entering numbers to false. And to achieve this, we can simply check if error is actually not nil, which means we have an error. And if we have an error, that means that the user did not enter a correct number, and that could be our exit criteria. So that here we then actually set is entering numbers to false if error is not nil. So if we have an error, then we'll set this to false, and then this condition here will no longer be met, and therefore we will not continue looping anymore. So we'll then make it out of this loop. Now, whenever you have a statement like this, where you check some condition to then set some other variable equal to a Boolean, you can also shorten this and just grab that condition here and set is entering numbers equal to that condition and get rid of the if statement. Then you avoid the extra if statement and you still get true or false as a result of this check, and we then store this here in is entering numbers. So as soon as we got an error, this will now store false as a value, and that will then exit out of our condition in the end. Now thereafter, we can therefore format and print our result colon v, maybe even add a line break thereafter with /n, and then just output the sum like that. Now we also might want to give the user a little bit more information at the beginning of this calculate sum manually function and print a new line where we say keep on entering numbers. The program will quit once you enter any other value, so that we also inform the user when this program will finish eventually. And with that, we are now still using the for loop, but in a slightly different version. And that's another way of using the for loop and another example for how the for loop can help us in specific scenarios. So now with that, if we run this program again and we use option number 3 now, we have to keep on entering numbers, and now I can enter 5, and it finishes immediately. Now why is that? Why is it stopping immediately? Why doesn't it keep on looping? Actually, because I have a tiny yet important logical error here in line 80. It's true that we don't need the if statement here, but here we should check for equality. If the error is nil, then we want to have true here because we want to keep on looping. Only if the error is not nil, this should yield false, which it then does with this kind of check, and we should leave this loop. So we have to invert this logic to make sure we keep on looping as long as we have no error, and hence this yields true, and that we stop looping as soon as we do have an error, and hence this yields false. So there was a tiny flaw in that logic I had before. With that fix in place, if I now run this program again, and I use option number 3, I can keep on entering values, and as soon as I enter anything else like max or just A and hit enter, we stop and we see the sum of all those values here. So that's now also working, and it shows us a different way of using the for loop. Now, of course, a question might be when you should use which version of the for loop, and the answer really just is it depends. It's something that will come with experience. It simply depends on whether you just have some condition that will not be met anymore at some point of time, or if you really have a concrete number of iterations which you want to perform. Even if you don't know the concrete number in advance as a developer, but you might know them from some user input, as we do here in this example which we had before. So whenever you have a concrete number somehow, this version is great. Whenever you just have some condition, like we do have valid input, then this form of the for loop is the version that's probably going to be more helpful to you. Now we're making good progress. There's just one last version of the for loop, which you also should know, since it is also rather important and common to use. We have this last function here, which should be triggered if the user chooses option number 4. And here the idea is that unlike in option number 3, we don't keep on entering numbers after each other, but instead we just provide one input, which is a list of numbers, separated by white space or commas, that's up to you. And then we want to take that list, so that array or slice, which it in the end should be, and add up all the values in that list. And that is another common use case, that you have a list of data, an array of data or a slice of data or even a map of data, and you then want to go through all the values stored in that list, in that collection, and do something with that data. For example, add it up, send it to a database, whatever your application should do. And that's also a use case that is supported by Go and the for loop, just again another version of the for loop. So therefore, to implement this, let's go to this function, calculate list sum. And first of all, I'll tell the user which kind of input we want. Please enter a, let's say, comma separated list of numbers. That's what I want as an input. Of course, as I said, you can go for other separators as well. And then here we want to get that input. Now here I won't use get input number because we'll not get a single number but a list of numbers instead. So this function, which then tries to convert the input to a single number, would fail. So instead I'll just grab this part of the function where we get and clean the raw input, and I will simply execute that here to get my input number list actually. That's a more fitting name, which I want to use here. Input number list. And of course, here I'm checking for errors. And I want to return if we got an error. But I then also, of course, want to, again, print a message where I say invalid input. Something like that. Now with that, we got a number list in the end. And it's important to understand that when we reach that line, and we do have some valid input, we'll have some input which looks like that. A string, and then hopefully a list of numbers like that. comma separated with no white space after the comma, just commas as separators. And very important, it's a string, not an array or slice. It looks like a list to us humans, but technically it will still be a string. So in order to work with that and to have an array or a slice, we need to convert our string, which is comma separated, or maybe white space separated, or separated by semicolons, depending on what you chose. And we need to split that string and these separated values up and transform that into a real list, into a real array or slice. And thankfully, there is a built-in functionality in Go that helps us achieve this. It's again available on the strings package, just like replace was. And here we got the split function. And that function does what the name implies. It takes a string as a first parameter value, and then as a second parameter value, the separator by which we want to split the characters or the values in the string, and it will then return us a slice of strings. Very important. Note the square brackets here. We get back a slice of string values. So here, I want to pass in the input number list, and then as a second value, pass in the separator by which I want to split, and in my case, that's a comma. And just a comma. Not comma white space, not a semicolon, just a comma. Because I expect this kind of input. If you expect a different kind of input, if you expect a different separator, you of course need to change that separator here. Now, split then returns this slice of strings, and just that slice of strings, no error. And therefore what I get back are my input numbers, a brand new variable which I create here, which will be that slice of strings. And actually that's important. I named it input numbers because I will have numbers as values, hopefully, but technically, from a type point of view, we'll still be dealing with strings here. So we still have to convert the individual string values to real numbers then to perform a mathematical calculation. But we'll do this in the next step, because as a first step, I now want to again use a loop. I now want to loop through all the values in that slice, through all those individual values that we got by splitting up that string. And whenever you have an array or slice or map, you can use the for loop to loop through all the values in there. For that, you use another special keyword built into Go, which is the range keyword. And you add range in front of the slice or array or map through which you want to loop. So in my case, input numbers. Now this then, combined, gives you two values. It's like calling a function. It returns two values which you can store in two variables, which will then only be available inside of this loop. Just as we had the I helper variable before, now we also get two variables by using that special range keyword on an array or slice or map. And you can name these variables however you want, but the first value which you get here will be the key of the value if you are looping through a map, or the index if you are looping through a slice or an array. So I will name it index. And then separated by a comma, the second value which you get will be the concrete value, no matter if you are looping through a slice, array, or map. Now we create two brand new variables, and therefore we still need the colon equal sign syntax. And then we add curly braces after this line. And this will now go through all the values in this array and give us access to the index or key and the value of the different values stored in that array or slice or map. So here inside of for, we could now print those two values to the console if we're interested, to the command line. And I will actually do that with printf. I'll print the index and I'll print the value like this, and then add a line break thereafter, and I will then point at index and value like that. But of course, that's not the main thing I want to do. Instead, I now want to sum up all those numbers. And therefore, I'll add again another helper variable, sum, which starts at 0. And I want to add the value, so the number I got here, to that sum. For that, it's just important to keep in mind that value here will be of type string, because input numbers is a slice full of strings. And therefore, we first of all need to convert that string to a number. We need to parse it. And we can do this with strconf parse int, which we also used before already. We pass value to parse int, then 0, and then 64. And that will give us the number and potentially an error. Now we'll handle the error case in a second. For the moment, I'll use that good old underscore again to tell Go that I want to ignore that value. And I'll focus on the number for now. Here, that number will then be of type int64. By the way, here we need to add a colon, of course. We got a brand new variable after all. And then this will be of type int64, so we'll still need to convert it to a regular int later. But we can now use that number to set our sum equal to the existing sum plus number converted to an int by wrapping it in this int conversion function. And this should now go through all the comma-separated values the user entered and sum them up. So if I thereafter print f, I can output result and then output the sum here in the end. And maybe also add a line break if we want to. And that should now work. If we now save that and we run this application, and we choose the fourth option, we now have to enter our comma-separated list here, like 1, 5, 10. And very important, make sure you don't add any white space or other characters in there. Make sure you really just have numbers and then commas between them. And if I now hit enter, I get 16. So that is correct. And we also see that intermediate output here, where I output the index values. These are the indexes assigned automatically in the slice, and then the values stored for those indexes. And as I mentioned, you could loop through a map in exactly the same way. Then you would just get the keys which you assigned instead of the index values. And that's now how we can loop through arrays, slices, or maps. So now we learned a lot about loops. As a last step, I want to show you one important keyword that can sometimes be helpful when you are working with loops. Here, we could have an error when we try to parse the individual values that the user enters. Hence, we might want to handle it. So here we get an error, and then I want to check if error is not equal to nil, which means we have an error. And of course here, we could return to stop the function execution. Then the entire app would quit because the user entered some invalid value here. Now, that is something we can do, but it would be even better if we could just continue and ignore this invalid value, because maybe the other values in that list are correct. And that's where Go gives us a useful keyword that we can use inside of loops. And that's the continue keyword. Continue will immediately tell Go to skip the rest of the loop code and continue with the next iteration. So here that means that if we got an error, we'll skip this line. We will not try to use that number because we know that we got an error parsing it, but we'll continue with the next value in input numbers because maybe that works. So continue is a great keyword if you have scenarios like this where you might want to skip a single loop iteration, but you don't want to quit altogether. You also have break as a keyword. That would then quit the entire loop iteration, but not the function execution. So that might still be helpful if you got more code in the function that should execute. But here we need continue to not stop the loop execution, but just stop the current iteration and continue with the next one. And with continue added here, if we now run that and we choose that option, I can enter invalid values like max in that list, and still it finishes and gives me a result for all the numbers that I entered. It just ignores that value that can't be converted to a number. And therefore, continue and break are also important keywords you should be aware of. And that's it for this course section. We learned a lot about conditionals here. We started with if statements, which are super important for running different pieces of code based on different conditions. You learned how you can write if statements, that you can have else if and else branches, and that you can also have more complex conditions here. In the end, you just need a Boolean value here, so you can also just store the result of a condition or a Boolean value itself in a variable and use that. Or you put your condition in line with the if keyword, as we're doing it here. Potentially, you can even combine multiple conditions, as we are also doing it here, to really express the exact condition that you want to express to then execute this code if that condition is met. And if statements are super important because in any non-trivial program, you will have different branches of code that need to execute under certain conditions. And then we also have loops. Loops allow us to repeat code. And as you learned, we have different kinds of loops. We have loops where we loop up to a certain number or down from a certain number, but where we in the end have a fixed number of iterations. But we also can write loops where we just have some condition and will keep on looping as long as that condition is met, and will therefore have to make sure that at some point in our code we ensure that it's not met anymore. Otherwise, we'll have an infinite loop, which is rarely what you want because then your program would never finish. And we also learned how we can loop through a list of values, through a collection, like an array, a slice, or a map, with the special range keyword, and then these helper variables that we can assign to the returned values, the index or key and the concrete value. And that's useful whenever you have a certain operation that should be performed for every value in a collection. And with that, we learned about loops and if statements, two super important features. If statements also help us with error handling, something we have been doing a lot then since we learned it, since you should of course also handle cases where things can go wrong and you have no control over it as a developer. You can't prevent it, but now you can at least handle it. And therefore these are more key building blocks which you will need in basically any program you're going to write. Now, at this point in the course, we had a very close look at all those core features and all those fundamentals that you need to know when working with Go. Therefore, now I want to make sure that we practice all those features again, that we practice all those concepts again. And for this, we're going to build a complete project again, a project that will be a little bit more complex than what we built up to this point, but also a project that will use all those concepts we had a look at up to this point. We're going to build a little game, a game which we play in the command line, the Monster Slayer game. And in this game, we, the player, will fight some monster. We both have 100 hit points at the beginning. And then as a player, we got different options every round to attack the monster, to heal ourselves, or every third round we can launch a special attack against the monster. And whilst building this project, we're going to dive back into all those important concepts we explored throughout this course. And therefore, that's what we're going to build step by step together. Of course, you can also try building this on your own first. But since we'll have to merge all those concepts we learned, this will definitely be challenging, so following along step by step and maybe pausing the video sometimes to try out the next steps on your own might be the better approach. But definitely use the approach you prefer. In the next lecture, we'll get started creating that project and planning the application. So before we create a project, a module, or before we write any code, let's briefly plan this application. And for that, I want to sketch out the general game logic, the flow of this game. When we start the game, so when we basically run this application, then we will have two participants, the player and the monster, with 100 hit points each at the beginning, though that amount will be customizable. And we will then start a new round where we ask the player to choose an action. That action could be to attack the monster, to heal him or herself, or every third round to launch a special attack. So that's an action which is not always available, but which should only be available every 3 rounds. Now, if we perform an attack or a special attack, we will of course update the monster's health and reduce the hit points of the monster by the damage caused by the attack. And that damage caused, by the way, will be calculated randomly. The special attack will tend to produce stronger attacks than the regular attack, so it will cause more damage. But we're going to perform some random number calculation here, this time with real random numbers. If the player chooses to heal him or herself, then of course we'll also calculate a random number for that, but will not update the monster's health, since that hasn't changed, but instead we'll update the player's health. And then, no matter which action we chose, as a next step, the monster will attack the player. So once we updated the monster's health, or in case of a heal, the player's health, the monster will attack the player. We will also calculate the damage with a random number there, and then we'll update the player's health and reduce that by the damage caused by the monster. And once that happened, this round is over, and we will then check if we have a winner. So we will check if the player's health is smaller or equal than 0, and we'll do the same for the monster's health. And here I'll assume that if the player's health is smaller or equal than 0, the player will have lost and the monster won. If the monster's health is below 0, then the player won. If both health amounts should be below 0 or equal to 0, then I'll also assume that the monster won, because even though it died, it managed to kill us with its last blow. But of course, that's some logic which you could also change. Now, of course, we will not always have a winner. If we just had our first game round, there will be no dead monster or player at this point. And therefore, we either start a new round then if we have no winner, or if we do have a winner, if some health is below 0, then we will declare that winner and also write a little log file where all the rounds are logged. So where we can see all the rounds that were performed, which action the user chose in the different rounds, and where we can then also see the health amounts and so on. So even though it's a simple game to the outside, there is some complexity inside of it, and that makes it a great practice application for this course. Now that's the general game flow and the features I want to have. Let's now dive a bit deeper and think about the modules and packages that we want to create. And of course, that is totally up to you, but you learned that there is this difference between modules and packages. And therefore here we will have one module with some pseudo URL and then a unique identifier, which will be the module for our whole application. But then I want to split the application code into multiple packages. Not because we have to do that. We could work with one package only, and that also probably would be fine, but because I want to practice this package concept again. And therefore, I will actually split my code into 3 packages here, and that would be the main package, Then an interaction package, which will deal with outputting data to the user and getting user input. And the actions package, which will deal with calculating that attack and heal damage or value and updating the hit points. So that will be the packages I'll create, but of course feel free to change this and to split your code differently. And now with that, with the planning out of the way, let's now dive into some real code and let's start writing some code. Now to get started, as so often, I do have my brand new empty folder here. It's almost empty. I just have this VS Code configuration file here. And I want to start by initializing that module which we have, because this entire application, as laid out in the last lecture, should go into one module. Now you learned that for this, we can open this integrated terminal or command prompt here, and then run go mod init, and then choose a unique identifier, which typically has that URL format. So here I'll choose github.com, then my name, and then here I'll choose Monster Slayer as a unique name for this module, but this name is up to you. That created this go mod file, and with that we're already done for the moment with that, and we can now start writing some code. Now for this I'll add a main.go file. The file name is up to you, but I'll use this as a main entry point basically here. So I'll add main.go, and in there add my main package entry and add this main function, which will be the first function that should be executed when we run this overall module. So when we run this overall application. And that's why I have this main.go file now. I will also have some sub packages in there. I'll have an interaction package at the end and an actions package. And hence I'll already create the folders for those package code files, because you learned that packages go into subfolders. And then we'll add concrete code files that we need here step by step throughout this course section. For the moment though, let's get started with the main Go file, and let's start writing our overall game logic there. Now in this main function, in this main Go file, I want to manage the general game logic. So the general big steps that need to be performed as part of this game. And for that, I first of all want to start the game by showing a little greeting to the user where we welcome the user to the game. And then I want to start a new round. So with that, we already have two main steps here. Start the game, which includes the greeting, and then start a new round. And of course, that round should be repeated, or to be precise, a new round should be started right after the previous round finished, as long as we have no winner. If we do have a winner, I want to stop and I want to end the game. And that's the third big step, the end game step, where I wanna print some information about the winner of the game and create this log file. And therefore, I'll actually create three separate functions here. The start game function, which will contain this initial greeting. Then the, let's say, execute round function, which will hold all the logic for letting the user choose an action and so on. And then also the end game function, which will declare the winner and write that log file. And we'll populate this with logic step by step. Now, in the main function, I simply want to start by executing start game. Then at the end, I definitely want to execute end game. And we might pass some parameters into those functions later. For the moment, I'll start with very basic empty functions like this, just to lay out the general flow. And between start game and end game, I want to have a very important construct which we learned about in the previous course section. I want to have a loop. I want to have a loop that keeps on looping as long as we have no winner. And if you think about the loops we learned about, which kind of loop could that be? Is it a regular for loop where we count down from a certain number or up to a certain number? Or do we loop through a slice or an array or a map? Or is it that loop where we continue looping until some condition is not met anymore? Well, it's the last kind of loop. We have the condition that the game is still running, that we have no winner yet, and only if that condition is not met anymore, only then I want to stop. Therefore, I'll add a new variable, winner, and I'll set this equal to an empty string. And later, this will either be player if the player is the winner, or it will be a monster if the monster is the winner. Or, as it's right now, it's empty, which means we have no winner yet. So that will hold a string, and initially we have no winner. With that variable, we can now create such a loop with help of the for keyword, as you learned. And here I now want to keep on looping as long as winner is equal to an empty string with the double equal sign. That's my condition here, and therefore inside of the loop, so between those curly braces, we can now execute our logic for those different rounds. And to be precise here, I want to execute my round, so run this function, which will soon do something. And I actually do expect that this function here, execute round, should tell me whether or not we have a winner after this round. So this execute round function should actually return a string with the name of the winner. So with player or monster, or an empty string if there is no winner. So that's what execute round should return, and therefore we can update this winner variable by setting winner equal to execute round. Because execute round will return us that winner, and as long as it returns an empty string, that loop will continue looping. As soon as it returns player or monster, will be done. So that's now the general rough logic that I want to have here. Now it probably makes sense to start with the start game function and fill that with more life, since that will be the first function we execute, before we then dive into the very important execute round function as a next step. So let's now work on the start game function. In here, my idea simply is that we in the end show some greeting text to the user. I just want to show some greeting text and that's it. So therefore, I want to add some code in my interaction package because that's the package that should be responsible for showing some output on the screen, or later also responsible for writing to the log file and for getting some user input. And right now I want to show a greeting, so I want to show some text on the screen. Hence here in the interaction folder, I'll add an output.go file and add that to the package interaction, repeating that folder name as a package name, as you should. That's the way of adding packages to a module in Go. And then in here, I'll add a function print greeting. And now here's something very important, which I mentioned at the beginning of the course. This function here, print greeting, does start with a capital P. And you learned that the starting character of your functions and variables and constants is important. If it is a capital character, that means that other packages can use that function or variable. They can import that function or variable, so to say. If it would be a lowercase character, then this function can only be used inside of the interaction package, but the main package would not be able to tap into it. And that's not what I want, hence this capital P at the beginning is important. Well, and in here, I now just want to output some information. So for this, I'll use that format package, which you of course need to import, and I'll print a couple of lines here. I'll start with the first line where I say Monster Slayer, maybe like that, all caps, as a title that's output. And then I print a second line where I say starting a new game, maybe like that. And then a third line where I will say good luck. That's my greeting text, but of course you can also use or write some other text. Now that we added this output Go file and saved it, back in main Go, we can now use that interaction package here. For this, we just need to import it, and hence here at the top, I'll add my import statement, and I'll add it with parentheses right away, so that we can easily add multiple imports. And here, I now have to repeat my module name. So that's this name here, stored in go.mod, between double quotes, and then slash, and then the package name, which in this case is interaction, which is the folder name and then the package name in the code file in the folder. And with that, now on this interaction identifier here, we can now access print greeting and output our greeting here. And that's now step number 1. With that, we do have a way of printing that greeting. And actually, that's already all I want to do in start game. Of course, you could do more if you have more initialization work, like getting the user's name or something like that. But I'll keep it simple and focus on that. And therefore, we are now ready to move on to the execute round function, which will now be a bit more complex. Now in execute round, in this function, we got various things that we gotta do. We have to kind of keep track of the round number, because we have that special attack that should be unlocked every 3 rounds. We then have to ask the user what he or she wants to do and get that user input. And we then also have to kind of handle that user input and perform different actions based on the chosen action the user provided to us. So these are various steps, and we'll get there step by step as we did before. Now let's start by keeping track of the round number. For that, we can add a brand new variable at the top of this file, so a global variable that is available across all those functions, and that is the current round variable, which initially might be 0. And hence this is inferred to be of type integer, which is exactly the type I want here. Now I did add current round and start with 0 because with that, here in execute round, I can now increment it by setting current round equal to current round plus 1, or by using that shortcut which you saw before already, by using current round plus plus. So this adds 1 to it and stores it back into that variable in every round that we execute. And again, this current round will be important to find out if the special attack is available or not. So now that we keep track of the current round, we can actually already decide whether this special attack should be available or not. And for this, I'll add an extra variable inside of execute round, which I'll call isSpecialRound, and which should contain the answer to the question whether the current round allows us to use the special attack or not. Now, how do we find out if it's available or not? As I said, it should be available every 3 rounds. And therefore, what we can do is we can divide current round by 3. And if this works with this integer value, then we know it's a special round. If we can't do a division without creating a floating point number, then we don't have a special round. And Go has a helpful operator for us here that helps us with that, and that's the modulus operator. This operation is represented by the percentage sign character on our keyboard, and it looks like this: current round percentage sign 3. With that, we are trying to divide current round by 3, and the result of this operation will actually be 0 if it worked, and it will be the remainder that does not fit into the number we try to provide otherwise. So for example, if the current round is 1, then of course 1 times 3 doesn't work, so the result of this operation would be 1, because there is 1 remaining which we can't divide by 3. If we had 2 divided by 3, this also doesn't work, and we get 2 as a remainder. If we get 3 divided by 3, this works, and hence we get 0. If we got 4 divided by 3, this works once, but then we again got 1 as a remainder. 4 minus 3, we got 1 as a remainder, which can't be divided by 3. That's how this percentage sign operator works. And therefore we know that if this is equal to 0, performing this Boolean comparison here, this will yield true, it will yield false otherwise. And therefore is special round will store true if the current round is divisible by 3, and therefore only every 3 rounds. So we're using a little bit of math here combined with this special character to find out whether the special attack should be available or not. And we'll need this is special round for the next steps now. Because the next step now is to present the available options to the user and to then get the user input. As a side note, if you save the file, the auto formatting currently at least removes the white space between the variable, the percentage sign, and the number through which you try to divide. It will still work though, it just looks different. But with that, let's now continue. So let's now continue by asking the user for what he or she wants to do. And therefore we can again go into the interaction output go file and in there add a new function where I want to show the available actions. So I'll name it show available actions. Of course, you could also name it print actions or whatever you want to do. Now here, it will be important to know whether it's a special round, so whether we want to show the special attack as an option or not. And therefore, I'll accept the parameter here, which I'll also name is special round, or maybe special attack is available to have a very descriptive name, which will be of type bool. And that's how you add a parameter and set its type in Go. With that, we'll be able to check this parameter value to find out whether we want to present that third extra option or not. And inside of this function, we can now again use the format package and print a couple of lines of information. For example, we can start by saying, please choose your action. And below that, we maybe just output a bunch of dashes as a separator, like this. And then I want to show the available actions. And here I'll say action number 1 is attack monster. And of course, the exact text here is up to you, because that's only what we show to the user. And the second action is to heal yourself. Now, sometimes we also got that third action, and for this we need to check if this is true or not. And hence we need an if statement, which we learned about in the last course section, where we check special attack is available. Now we could say if special attack is available equals true, and that would be valid, but it's also redundant. Because if wants some expression that yields true or false, and since special attack is available already is such a Boolean, just looking into that Boolean is enough. And hence we can write this if statement like that, and then print a third option if that special attack is available. So here I'll then also output special attack as another option. And with this, we can go back to main Go, and here we can now add a new line of code where we use this interaction package and then execute show available actions, and very important, pass is special round as a parameter value into this function call. So this boolean is passed in as a parameter value. And with that, we do now show the appropriate actions based on the round number. As a next step, I now want to get the user input. I want to find out what the user entered and then perform the appropriate action based on that chosen option. Now, to work with that user input, I'll add another file here next to output Go in the interaction folder, and that's the input Go file, which, as the name suggests, should deal with the user input. And in here, I want to read the user input, and I then want to clean it and check if it's valid and so on. Now for this, first of all, let's assign it to a package, and that's still the interaction package here. And then we can add the function getPlayerChoice, like that. Starting with a capital G so that we can use it from inside the main package. Now here I also need to know whether it's a special round or not, because that will be important for validating that user choice. So here I'll accept the special attack is available boolean parameter so that we can use that inside of this function. Now in this function, I want to read and clean that user input and handle a potentially incorrect input, and therefore we'll need a reader. Now I will create that reader here outside of those functions so that we don't create new readers all the time, but we instead use one and the same reader whenever one of those functions is called. So I'll add a reader here, which I get from the buff.io package, which we need to import. And that reader is then created by calling that new reader function. And now we need to let Go know from where we want to read input or data. And for that, we use the OS package, which you therefore also need to import. And we reach out to standard input here, like that. That creates such a reader, and that's what we did multiple times in this course before already. Now in getPlayerChoice, I wanna read that user input, but actually I'll do it in even another function, which I'll add here, because getPlayerChoice should instead do a more higher level evaluation of what the user entered. And that other function, which I'll add now, should do the actual reading and cleaning. You could do it all in one function. I just want to keep the code a bit more readable and split up to have smaller individual pieces. Here I'll name this function getPlayerInput, because that will be the function that really deals with just getting the raw input. And I start with a lowercase g here, because this function here actually will only be used inside of this package. Now inside of this getPlayerInput function, I now want to output something with the format package, and I'll output it here even though it's the input.go file, because it's tightly coupled to getting this specific input. And I'll output with the print function here, so not println but just print, because that text should now be in the same line where the user then enters his or her choice. And I'll just say your choice here, add a blank so that there is some spacing to the user input, and then proceed with getting that input. And here I'll use the reader to read a string, and as we learned it before, I'll read it up to that line break byte, So until that line break is added by the user. And this then gives us the user input and also potentially an error. And I'll assign 2 new variables here because these are not variables that we would have declared before. Now, we did learn about error handling, and we absolutely should handle errors here, at least to some extent. In this function here, I don't want to show an error message to the user. Instead, if there is an error, I want to forward it to getPlayerChoice, which will soon call getPlayerInput, so that the actual error output is handled there. So here in getPlayerInput, I'll just check if error is not equal to nil, which means we have an error. And in that case, I want to return the error along with an empty string. Why along with an empty string? Because of course getPlayerInput should normally return that player input and only also return an error if there is one. So getPlayerInput actually will have 2 return values, and hence I add parentheses here. And the first return value is the string, which is that fetched user input if we have one. And it's only sometimes an error. I mean, we will always return 2 values, but error hopefully very often is nil, and string hopefully very often is the actual user input. But here, if we have an error, then I will actually return an empty string as a first value, and then this error as a second value, because then we do have an error. But if we make it past this if check, we know that generally reading that user input worked. And in that case, I want to clean the input and remove that line break. And therefore here, I'll then set user input equal to strings, using that strings package, which you need to import, of course. And on that strings package, we have that replace function you already saw before in the course. And here I pass in the old user input. I look for the line breaks. I replace those with an empty string to remove them, and I do that for all occurrences by passing -1 here. And then we have that cleaned user input, so then here I'll return that cleaned user input and return nil as a value for the error, because we have no error here. And that's the next step. We are not done though. Now we need to connect getPlayerInput to getPlayerChoice and really get that choice and check whether it's a valid choice. So in getPlayerChoice, I now want to actually call getPlayerInput and then use that cleaned value to kind of map that into a concrete choice. So here I want to call getPlayerInput, and what we get back is the player choice and potentially an error. Of course, those variable names are up to you, and we will create them as brand new variables because of course we haven't declared them before. Now, if we do have an error here, if that's not nil, then we know that something went wrong with getting that user input in the first place. So in that case, I'll format and print a new line of text where I say fetching the user input failed. Please try again. And I'll work on that try again part in a second. Before I do that though, I want to check if we do have a valid choice in terms of our game. So if the choice is 1 or 2 or 3, but 3 is only allowed if a special attack is available. Because keep in mind that we got 1, 2, and 3 as numbers, which the user should enter to make a choice. So we want to check if the choice is one of these numbers, and if it's 3, if that special attack is actually available, so that the user didn't choose an action which actually shouldn't be available. We can do this with another if statement here. We can check if the player choice is equal to 1, which is of course fine. And in that case, I want to return from that getPlayerChoice function and return, let's say, attack. as an identifier. This text is up to you. We'll use it later as an identifier in other parts of this application. Of course, for that to work, I need to make it clear that getPlayerChoice will return a string, so I'll add string here as a return value, as a return type. So that's what I return if the player choice is 1. Now, I also got the scenario that it's maybe 2. And that screams for an else if statement, where we now check if we did not make it into this first branch here, if the player choice maybe is 2. And if that's the case, then I want to return heal as an identifier, because 2, of course, is healing. Now maybe it's neither 1 or 2. So we want to check if player choice is equal to 3, but we only accept this if the special attack is available. So I check if and special attack is available is true. And I see that I have a typo here. That should be available with an A here. So we need that combined check here. And only if both conditions are true, we make it into this branch. Because if the user just entered 3, but the special attack shouldn't be available, we definitely don't want to perform a special attack. So we only return special attack here, something like that, if we really have the choice and the choice is allowed. Now, if the user entered anything else, then we don't want to accept that choice. Then instead, I want to actually output this message, which we also output in case of an error. And since that will be the case either if neither 1 or 2 or 3 with the special attack being available was chosen, or if we have an error, we can also write this code differently and not add this else branch, because that's not a must do, and also not add this error check, but instead just output this message here like that. Because we know that if we reach this point here, the player made a choice that's not accepted. And then I want to ask the user again. The question now just is, how do we ask the user again? And the answer is, we can put this into a loop. We can put this into a loop that keeps on running until we have a valid choice. So that again screams for a for loop, since that's our only way of creating a loop, but it screams for that special version of the for loop where we keep on looping as long as a certain condition is met. And the condition here actually could be true, hence creating an infinite loop. But now we can move that code into that loop, and the idea behind this now simply is that we'll stay in this infinite loop until we make it out of there with the return keyword. So until either 1 or 2 or 3 with the special attack being available was chosen. Because if the return keyword is reached, that will return from this function, it will stop the function execution, and it will therefore also stop this infinite loop. So it's not really an infinite loop, we just don't end it by changing this condition, but instead we end it by returning. Of course, if we write it like this, we don't really do anything with that error. We implicitly handle it by showing this error message here if we don't make it into one of these branches. And hence we should tell Go that we don't use this specific variable, and hence use that special underscore placeholder that signals to Go that will not use that value. In addition, Go here will complain that we never return after this loop, even though we say that we'll return a string in this function, because Go doesn't really understand that we'll never reach that part after the loop, because it's an infinite loop. So therefore, to make Go happy here as well, we can just return an empty string or a tag as a default value here, even though we'll realistically never reach that part of the code. Now I'll reformat that and save this, and that's now one way of writing this. Now here, Go actually gives us a hint that if that's the kind of loop we write, we can also get rid of true and just write it like this. And then it also does understand that this is an infinite loop which will never leave. So then we can remove that return statement at the end. And that's now one way of asking for input until we have valid input. Please keep in mind that here the current round number will not change because that's really just a loop for getting input. So the special attack will never be able if we just keep on entering invalid input. The round number won't change. We just give the user more than one chance, to be precise, an infinite amount of chances to enter a valid input. That's what we do with this code. And with all of that, ultimately, we'll then return an identifier for the chosen action. We can then use that in main Go. Because here in execute round, we thus far presented the options. Now we want to get that user choice. So here I'll add a new user choice variable and set this equal to interaction and then get player choice. And to get player choice, I also pass my isSpecialRound boolean because that function needs to know whether the special attack is available or not. And now it's a good time to see whether everything works. So therefore here, I will now just format, just output the chosen action, so the user choice. And for that, of course, I temporarily added that format package. And in execute round, I'll return an empty string as a dummy value for now, which will keep that outer main game loop running here, which therefore is also an infinite loop, but we will be able to exit out of that manually with a special key combination, which I will show you in a second. So therefore now, let's save all those files, and then let's actually run this program. And we should see our greeting here, and we can choose an action now. And because it's the first round, we only have the actions 1 and 2 and not the special attack, because this first round is not divisible by 3. So if I choose attack monster here, if I enter 1, then you see this is output here. So that's coming from this line of code here. And we then are asked for another action because a new round started. We're not outputting that a new round started. We could do that, but that is what's happening here. So if I choose 2 here, then heal is confirmed and yet another round starts. And since that's the third round, we now can also use special attack and choose 3, and that works and is confirmed. Then we got a new round, the fourth round, which is not divisible by 3, at least not without a remainder, and hence we only have the options 1 and 2 available now. And here, if I now try to choose 3, so if I try to cheat the game, then you will actually see I get this fetching the user input failed warning, and I have to try again. And I can try again as often as I want, it will never be accepted. The same is true if I enter a totally different number or something invalid. If I choose 1 again though, it is accepted and the next round starts. So that is working up to this point. Now we can quit this infinite loop here with the Control-C character on your keyboard, and that should then stop that execution and we can close this command line. Because now, of course, we're far from done with the game, but we are at least fetching all that user input successfully. Now we got that user choice here, and that will be a string which has either the value attack, heal, or special attack. So therefore, we want to check for these 3 values here in main Go when we proceed. Hence here we need another if statement in execute round. And we want to check if user choice is equal to attack, which was our first identifier, in which case we want to perform that attack action, for which we have to add the code soon. Or maybe else if user choice was equal to heal, in which case we want to perform the appropriate action. Or else we know it has to be the special attack, because user choice only returns these three kind of values. We don't need to check whether the user is allowed to perform a special attack or not, because we already do that inside of getPlayerChoice. So in main Go, we don't need to check for that. Instead here, we now want to trigger the different actions and the logic that belongs to those actions. And that leads us to that actions folder. In that actions folder, I want to store the code that is responsible for executing those specific actions. So I'll add an actions.go file in there. The file name is up to you, but it will belong to the actions package. That's important. So the same name here as we have it for the folder. And then in there, I want to add a couple of functions. The first function that I want to add is the attack monster function. And that could be a strong attack if it's a special attack, or the regular attack. We could also create two separate functions, but actually the only difference between those functions would be the min-max values, which we will use for calculating a random number. And therefore instead I'll just accept a parameter, which I'll name is special attack, which is a Boolean value, and we'll use that parameter inside of the function to change those damage boundaries. We also need another function which is named healPlayer, which will do what the name implies. In there we want to have the code for healing the player. And we also must not forget that the monster is allowed to strike back. And that's another action that will be performed in our game, not by the player, but in the game as a whole. So in here I'll add another function which I'll name attackPlayer, which is that counterattack. So these are the three functions we need here. For all these functions, we'll have to calculate a random value, the damage or the heal value. And hence I'll add a fourth function, which I'll name generate rand between, because I want to generate a random value between two other values. Now this function starts with a lowercase character, because it will only be used inside of the actions package. The other functions start with uppercase characters, because they should be accessible from inside the main package, or from inside other packages in general. Now let's work on that random number generation. And I briefly touched on this before, but I actually showed you an approach that didn't fully work as shown. Because in theory, generating random numbers is simple in Go, but to get real random numbers, we need to create a so-called source and seed for that random number generation. Otherwise, we'll always get exactly the same number. And we'll generate such a source and a seed right now. For this, I'll add a new global variable here in this actions package, in this actions Go file, which I'll name rand_source. And I'll set this equal to something from the rand package. And here you should make sure that you use the math rand package. So not this package, but instead this package, the math rand package, because that's the package that gives us this random number generator that we need here. And of course that needs to be imported therefore. And once we got this rand package, we can now execute the new source function on it. Now this will set a source, and the source here should be some pseudo-random number, which means not really random, but also not the same every time. And a perfect source here always is the current timestamp. For this we can use the time package, which also needs to be imported, and execute the now function there, and then also the Unix nano function on the result of the now function, which will give us the current timestamp as an integer number, basically. And that's then our source for the source, so to say. So this gives us a source which we can use for generating random numbers. Based on this source, we now need to create an actual random number generator by using rand new. And to new, we now pass our source, our rand source. And now it's this rand generator which we can use for generating real random numbers. So for this here in generate rand between, I actually want to return a value, and that value will use the rand generator. And here I want to execute the int n function. This is a function that will generate a random integer number between 0 and then some upper limit. Now actually generate rand between should not generate a number between 0 and some other number, but instead between two boundaries which are received as parameters. So I'll accept a min integer parameter and a max integer parameter, and will then later return an integer, the random number. And int n only takes one parameter, unfortunately. What we can do here is simply subtract min from max, and then add min back to the random number that was generated. This will effectively give us a random number between min and max when this function here is executed. And we'll use this function in the three other main functions we got here. And let's maybe start with attack monster now. In attack monster, I now want to calculate the damage value that will be dealt. And for this, we can add a damage value variable and declare it and initialize it in one step. And here I then want to execute this brand new generate rand between function. And now we want to pass in the upper and lower boundaries for that damage. And those boundaries also will depend on whether it's a regular attack or a strong attack. Now, for that we can add new variables here. And we could simply add a variable min attack value, which we maybe set to 5, and add a max attack value variable, which we maybe set to 10. And you can play around with different numbers here to fine-tune your game and the game balance later. Now we might want to change those variables if is special attack is true. Because if it's a special attack, we want to deal more damage, and then min attack value maybe should be 10, let's say, and max attack value should be 20. And now we can pass min and max attack value to generate rand between, pass in min attack value and max attack value, and then we got a damage value, which is a random number between our two boundaries. Now we need to use that damage value to reduce the player's health. And for this, we could manage the health as a global resource here inside of actions go, or we simply return the damage value that will be caused and let the main Go file do the health management. And now it's up to you whether you want to manage that health of the player and the monster in actions Go or in main Go or in some other part. And different arguments could be made for different places of managing this. I will do it here in actions Go, since the actions do directly influence the player and monster health. So in here, I'll add a brand new variable below the random generator, which I'll name current monster health. And that's 100 initially, let's say. And I'll also already add a current player health, which also starts at 100. Though, of course, you can also play around with these values to change the balance of your game. And now, damage value should affect the monster's health here, since we are attacking the monster. And hence, I want to set the current monster health equal to current monster health minus damage value. And there also is a shortcut for this, which we haven't seen before. Instead of writing it like this, which also would be fine, we can also write minus equal damage value. And that's the same as the form you saw before. So that's another shortcut, which of course also exists for plus if you need that. With that, we are adjusting the current monster health. And for the moment, this should be all we gotta do here, though we'll also revisit this function soon enough. Now let's also work on the heal player and attack player functions. And generally, we can copy the logic from attack monster over to heal player, but of course now adjust it a little bit. We don't have a special attack, and it's also not the min attack value, but the min heal value and the max heal value. And the concrete values which we want to use here might be 10 and 20. Whoops, 20. Those values, of course, are up to you though. And then we want to calculate our concrete heal value based on that min heal value and that max heal value. And we then want to update the, whoops, that should be named heal value. And we then want to update the current player health by adding, now you see this shortcut as well, the heal value. There's a little gotcha here though. I don't always want to heal the player by the full amount because you shouldn't be able to heal above 100. So the initial health of the player, you should not be able to heal yourself up to 110 or something like that. Hence, to avoid this, I actually want to calculate the difference between the max health and the current health. So I'll simply add a health diff variable here, which is 100 minus current player health. And I then want to check if the health difference is maybe greater or equal than the heal value, which means we can heal for the full amount we calculated, in which case I want to update the current player health as we did it down there. So I'll move that line here into that if block. But else, if the difference is not greater than the value we want to heal for, I only want to heal up to 100. So in that case, I'll just set current player health equal to 100 to go back to the maximum, but not above it. And that's now the heal player function. And last but not least, for attacking the player, we can again copy the logic from attack monster and paste that into attack player. But of course, we also have no special attack here. And we definitely also want to fine-tune the values. And the min attack value here is maybe 9. And the max attack value is 13. Because the monster should, by default, hit a little bit harder than the player does with his or her default attack. And then we calculate the damage, and we then update the current player health instead of the monster health, because we launched an attack against the player. And that's now also this function finished. But there now is a little bit of improvement potential before we continue with the main game logic. And that improvement potential is related to those numbers, the damage and the health numbers, which I have everywhere. I have a problem with those health and damage numbers which are everywhere in this actions go file. If we ever want to change our game balance and we, for example, decide to change the default player health to 120, we have to change it here, but then also down here and down here. And I'll revert this here, but this could be a problem. And if we ever decide to change some damage numbers, we also have to scan through this file to find the appropriate place for changing those numbers. And actually those min and max numbers and the initial health values would be perfect constants, because they should never change once the game is running, so once we've finished building this application actually. And therefore I'll add a new file, the, let's say, metadata.go file, which should hold a couple of constants that are available inside of this package. So I'll also assign this to the actions package. So the same package as we have for the actions.go file. And in this metadata.go file, I now want to define a bunch of constant values. And I'll start with the health values. I'll add a constant named player health, and I'm writing it like this because that's kind of the convention for naming constants in Go. You very often use those all caps names where you make it very clear that these are constants. So it's all caps here, not because I want to be able to use it in other packages, but because I want to clearly mark it as a constant in all the places where I will later use it. And I'll set this to 100 here. And the same can then be done for the monster health. So I'll add another constant, monster health, which also is 100. And then we can add more constants for the damage values. We can add a player attack min damage constant, for example, which could be 5. So that same value which it shows here as a min attack value. And we'll do the same for the max attack value and for the heal values and the special attacks and so on. So I'll copy that and also set my player attack max damage constant and set this to 10. And then repeat that for the special attack. So here we have the player special attack min damage and special attack max damage. And for the min damage, that's 10. For the max damage, that's maybe 20. We then also have the heal values. So here we have the player heal min value, and here we have the player heal max value. And for the min value, that's, let's say, 10. For the max, that's 20. And then we also have the attack values for the monster. So here we have the monster attack min damage, which is maybe 9. And then we have the monster attack max damage, which is 13. And with all those constants defined back in actions.go, we can refer to those constants instead of hard coding those values here. So for the current monster health, we can reach out to the monster health constant. And the same for the player. Here we got the player health constant. For the min attack value here, we got the player attack min damage. And for the max, unsurprisingly, the player attack max damage. In case of the special attack, that's the player special attack min damage and the player special attack max damage. Now, when it comes to healing, we don't even need those extra variables anymore, therefore, we can get rid of them and just use those constants directly here as values for this function. Here we have the player heal min value, and here we have the player heal max value. For calculating the health difference, we now again use the player health instead of again hard coding 100, and we also use the player health down there for resetting the player health. For attacking the player, we of course have the monster attack min and the monster attack max damage. And the huge advantage now is that if we ever want to change the balance of our game and we want to change one of these values or multiple of these values, we can just go into the metadata.go file and change them here all in one place, and the other file, the actions.go file, will automatically work correctly. And that's why I do strongly recommend that you embrace and use that constant value feature for cases like this. So by now we got our actions defined and we are using constants for those important values like health and the damage values. Now the goal is to go back to main Go and call those different actions based on the choice the user made. So here, if the choice is attack, I wanna execute the attack monster function. And for this, since that's inside of an extra package, we first of all have to go to main.go and import this extra package so that we don't just include this interaction package, but also this brand new actions package. And with that import added here, we can go down to execute round. And if the user choice equals attack, I now wanna use this actions package and then execute attack monster here. Now attack monster needs to know whether it's a special attack or not, and here we got the regular attack, so passing in false is just fine here. If the user choice is heal, then we want to execute the the actions heal player function, which does not require any parameter. And in the else case, we know that it's a special attack, so then we again want to execute attack monster, but now pass in true, since we do have this special attack. And that will now make sure that we do launch our attack against the monster. Now, of course, that's not all, but the monster then always should attack us back. So no matter which choice we made, thereafter, after our action has been executed, I want to execute attack player because that's always what will happen thereafter. And now we are performing all those actions. Now we need to find out whether the game is over or not. So whether we have a winner or not. And for this, we need to know if the monster health or the player health, or both maybe, are equal or below 0. Now we have multiple ways of finding out whether that's the case or not, but I think one of the easiest ways is to go into our action functions there and return some values. For example, we could return the monster and player health for that. So here in attack monster, we can return two values, the current monster health and the current player health. Simply because in all those actions, I always want to return the latest player and monster health so that we got that information. For this, we can, of course, for example, use multiple return values. So here for attack monster, I want to define my different return values. And here I want to define that I will return two integers, my two healths. And then here we can return current player health and current monster health. And now we can copy that return statement and do the same here in heal player. Of course, there the monster health will not change, but in the first function, the player health didn't change. And nonetheless, I always want to return both health amounts so that we got the full available data in the main.go file later. So I'll copy those return types as well and add them here after heal player. And then also add them after attack player. And in that case, also return those two values. And that's just one way of implementing this. A potential downside or aspect which you could consider to be not ideal is that I am returning variables here which are actually not specific to those functions, but which are global variables in that package. So instead of doing that, we could also make them globally accessible instead by using uppercase characters though. Then we could directly access those variables from inside the main.go file, but a disadvantage of doing that could be that we can easily manipulate them from inside main.go, and even if I don't do that here, I also want to avoid that I accidentally do that. So I'll keep them to be local variables, which are only available inside of actions, and I instead return their values once the action functions are executed. But you can definitely find different ways of writing the code for that, and there will be different ways of achieving this. Here, I am now always returning these two health amounts, and therefore when we execute those actions in main.go, we of course can now store those health amounts. And we could, for example, add new variables here. Let's say we add a variable player health, which is an int and has no value initially. And then we have the monster health, which is an int and has no value initially. And then here we get back our data, and we know that we always get back the player health first. That's the order in all three functions. And therefore here in main.go, we can always say player health, comma, monster health equals, and then store those returned values. And do that for all the places where we call an action function, including the attack player function call here. And now that we got those health values, we can use them to find out whether we have a winner or not. After all the actions have been performed, we can add another if check to find out if the player is dead or the monster is dead. So here we can check if player health is smaller or equal than 0, and in that case the player will have lost and the monster will have won. And that's just my definition. You could of course also check for the monster health first and say if the monster is dead, I don't care whether the player is dead as well. But here I will set that game to behave like that so that we only win if the monster is dead but the player is not. So if the player is dead, it doesn't matter if the monster also is below 0. In that case, the monster will always have won. And since execute round in the end returns the winner of the overall game in the end, I will of course return monster in that case that player health is smaller or equal than 0. Else if the monster health is smaller or equal than 0, so the player health is not smaller or equal, but the monster health is, I will return player. And if neither of the two conditions is met, nothing will happen here, and we instead return this empty string, which will keep the outer loop, this one here, running, which it should. So that's now one way of checking for a winner. Now we're not done with the round logic yet. I soon also want to log and show some information, but for the moment I want to keep it like this and instead focus on the end game logic and there output some information about the winner so that we know once the game is over. However, before we do that, you'll notice that if you save this file, we get some yellow squiggly lines here. And we get the warning that the monster health and player health here is never used. Now clearly we are using both pieces of data here. So what's up with that message? Well, you must not forget that we always attack the player and we get back the latest player and monster health there. So therefore, indeed at the moment, we aren't doing anything useful with the player health and monster health we get back before we attack the player. Because those variable values which we get here are always overwritten by line 44. So indeed, storing those return values in those 3 lines here has no effect. And since that's the case, indeed for the moment, we can delete that code here and work on those functions again a little bit later to change their logic, since we only need the data from the attack player function. And since that's the case, and I want to keep all those functions in line, attack player, heal player, attack monster, I want those functions to be similar. Because that's the case, I will actually not return my health amounts here and delete those return values for attack monster and heal player. So refactor that code and get rid of that. And also remove it here for attack player, get rid of the return values there as well. And instead add a new function, get health amounts, which is responsible for just what the name implies. Here I want to return 2 integers, and here I want to return the current player health and the current monster health. Now this is a function that starts with a capital character, so that back in main.go, we no longer extract that data from calling attack player, the player health and monster health, but instead, after we attack the player, I execute actions, get health amounts, and I get my data from there. And then I save everything. This is simply, in my opinion, a little bit of a cleaner approach, since we now have a dedicated function for giving us those health amounts, and we got those action functions which at the moment don't return anything. And I hope I could make it clear why I'm using this approach. Because getting the data from all the functions was redundant, and then having one function which returns different values than the other functions, even though it otherwise does pretty much the same thing, felt a bit inconsistent to me. That's why I introduced this brand new extra function. And with that, let's now focus on ending the game and giving us some information regarding that. Now, when it comes to ending the game, I in the end just want to output some information about the winner of the game. And since I want to output some information, that screams for the output.go file in the interaction folder. In there, I'll add a brand new function, a function which I will name declare winner, though the name as always is up to you. There, I expect to get the winner as a string, since that winner is not determined in this function or this file, but instead in the main Go file. And then here I want to use the format package to, first of all, print a little separator. Hence, I'll copy this line here, where I output some dashes. And below that, I'll then print another line of text where I want to say game over, maybe then repeat that separator, and then also, last but not least, output the name of the winner. For this, I'll use the printf function so that we can do some custom formatting, and I'll say placeholder, %v placeholder 1, and then a line break with /n. And we then have to pass in a value for that placeholder, as you learned, and that should be the winner, so that parameter value which we are getting. So that we say monster1 or player1. And of course, you could fine-tune this. You could accept more parameters, for example, the final health values, and output those as well. But here, I'll keep it simple and just say who won. And then back in main.go, inside of the endgame function, I hence want to reach out to the interaction package and call declare winner and forward my winner, which I therefore also expect as a string parameter value for the endgame function, so that I get it here and I then forward it to declare winner. And with that, we just have to make sure that endgame gets called with that winner information. Thankfully, we have that here in main, so we can just pass winner to endgame. And we'll only reach this line of code once we made it out of this loop, which will only happen once we have a winner. So if everything worked here, we should be able to play this game, even though for the moment we'll not see any information on the individual rounds. But we'll see a winner at some point. So if I run this application now, we can, attack the monster a couple of times, maybe also with the special attack, and maybe heal, and special attack, and attack, and attack. And at some point the game is over, and as it seems here, we lost and the monster won, but of course at the moment it's pretty much a black box to us because we have no information about the health amounts, about the amount of damage we dealt, and we also have no log of the overall fight. But these are features we are going to add. It looks like our game is working though. And therefore, with that, let's assume it works and save that state or quit that terminal. And now let's output more information after every round so that we also inform the player about the health amounts, about the damage dealt, and so on. Now, in order to output more information about the different rounds, I want to go back to the output.go file because I want to output more information. And in there, I'll add a new function. A function which I will name print round statistics. like this, because that's what I want to do. I want to output information about the current round that just finished. I want to output the health amounts, which action was performed, how much damage was dealt, or how much we healed for, and so on. Therefore, this function will actually require quite a bit of data. It needs the health amounts, the action identifier, then the values, the damage values and heal values. And we could accept a pretty long list of parameters. That would be possible, but that would make it pretty difficult to call this function because we then always have to remember the order of parameters and so on. What we could do instead is that we use a struct for defining our own data type that groups all that related data together. Because you learned in the course that this is the idea behind structs, that we can group related data together. And therefore, that's what I'll do here. At the top of the file, so that we can immediately see it if we dive into that file, I'll define my own struct by using the type keyword and then any name of my choice. And I'll name it round data, but of course the name is up to you. I will start with a capital R though, because I want to be able to use this struct type outside of this file and package as well. So I'll start with a capital character, and then the struct keyword, and now we define the general, structure of this type of data. And now here we want to store various pieces of data. For example, the action that was performed. For this, I'll add an action key here, and I also start with a capital character here because I want that key to be available outside of this package as well. When we use this struct outside of this package, I want to make sure that we can also read and write to this specific key outside of that package. Hence, the capital character here at the beginning of this key name, and this will be of type string. Then I also want to store the player attack damage. Of course, we won't have that attack damage for every kind of action. For example, if the monster attacked or the player healed himself, then we won't have that data. But then we'll just leave this empty. We'll just not store any data in there, and that would also be fine. If we do have data, it should be an integer though, so a number. We'll also have the player heal value sometimes, and that will also be an integer if we have it. And then the monster attack damage, which is also an integer. And then the two health amounts, the player health, which is int, and the monster health, which is an integer. Now those key names are up to you, but these should be names that are pretty descriptive of what's stored in them. If I now press the format shortcut, this is also formatted to be a bit more readable. Now that we have this round data struct, we can expect in our print round statistics function that we get one parameter which is of that type. So that we get our round data here, which is of type round data. And to be very precise, I want to get a pointer to such a value instead of the value itself, so that we avoid unnecessary copies. That is something I talked about in depth throughout the course, especially, of course, in the pointers and structs sections. And passing a pointer instead of the value simply helps us avoid unnecessary copies and therefore keeps our memory a bit less occupied. And with that, once we got that data, we can utilize it here in this print round statistics function to log some information to the command line. So to show some output to the user. We will not write to a file yet, we'll do that later. Here I really just want to show some data to the user in the command line. So in here I want to start by checking if round data action, using the dot notation as we do on structs, is equal to attack. So if we have a regular attack. And here I'm using the dot notation, even though theoretically we would have to dereference the pointer first, because you learned that Go gives us this shortcut for structs where we can use a pointer to a struct like the struct value itself. It's a little simplification provided to us by Go. And if that action is attack, then I want to output some formatted text with printf, where I say player attacked monster for value placeholder damage. Damage. And then a line break with /n. And the value for the placeholder should be round data dot player attack damage. Now I'll copy that and add an else if case. Maybe the round data action wasn't attack, but instead it was a special attack. So I'm using this identifier, which we also defined in input Go. Here we are returning this special attack identifier if the player chose free, and now I'm checking whether that was the action that was performed. And if that was that action, then I instead want to say player attacked monster for damage. So that doesn't change, but we maybe say player performed a strong attack against monster for damage. Of course, it's up to you which text you want to choose. And then we still refer to player attack damage. So that same field we used before, but now if that was the action, that should contain a different value. And we'll make sure that we get such a struct with the correct values in the main Go file very soon. For the moment, we just prepare that text that should be output. Now, if the action was neither an attack nor a special attack, then it should have been a heal. So we can check for that or just assume that it was a heal since we have no other actions left. And hence I'll just add an else case and then again output some information here. But this time I'll say player healed for and then my placeholder. And then I want to refer to round data player heal value. Now, no matter which action we had, we know that always thereafter the monster will have attacked back. And therefore, in this case here, I want to output monster attacked player for some damage. And here we refer to the monster attack damage in our struct. And then I also want to output the health amounts. And for this, I'll just say player health colon, and then output some value. And the value which I output here is, of course, the player health. And then I output monster health, and I output monster health here. And that now prints all the information about the round that just ended that I want to output. Now, of course, we need to call this function from inside the main Go file and make sure that we pass in a struct that contains all the data that we expect. So let's now work on calling print round statistics. For this, back in main Go, in execute round, so in this function, I want to output my round statistics once we performed all actions. So once we got those health amounts, basically. Then I want to use the interaction package and execute print round statistics. But now we need to prepare such a struct. And for this, I'll add a new variable here, round data. Name is up to you, of course. A brand new variable where I want to, store my struct in. For this, we could use the interaction package and access round data. So this struct, which we can access because it starts with a capital character. Or alternatively, we don't do it like this, and we instead create a creation function here that creates such a struct for us. Some new round data function that creates a struct for us. And that would also be perfectly fine, but I want to practice that struct literal notation here again, and hence I'll create such a struct literal right inside of main.go also to show you that you can export and work with such a struct definition in other packages as well. And now here we need to populate all those values. And we can omit the key names if we keep the order of values that we defined here. But I will repeat the key names here to make it very readable if we just glance over this code here, which kind of different values we are populating. And therefore I'll start by setting the action key in my struct to a certain value. And the value I do want to set here is the action that was chosen by the user, and that's of course my user choice here in the end, because that is attack, heal, or special attack. So the value stored in user choice will be the value for this action key. Now we also need to populate the other values, and that's quite easy for the player health, because we got that here in this variable. So I want to store player health here, and the same is true for the monster health. Here we got that monster health variable. But what about the heal or damage values? Those are calculated inside of actions.go, but we then don't have access to those calculated values. And that's something which I want to change therefore. These attack monster, heal player, and attack player functions should again return something. They should return the damage or heal values they derived. So attack monster in the actions.go file should return an integer, and that integer is that damage value that is derived here. In heal player it's the same. There I want to return an integer, and the integer value that I do want to return is the amount for which I healed. Here it's just important to differentiate between these two cases, and therefore actually if we healed for the heal value in this branch of the if statement, I'll return heal value. If instead we are in the else case, I'll return the health diff, because that's then what we actually healed for. And in attack player, we of course also want to return an integer, and that again is the damage value. Here the damage value the monster dealt to us as a player. And with that returned back in main Go, we can now store that data again, but this time we'll also use it here. So here I can now add brand new variables, player attack damage, which is an integer, and player heal value, which is an integer, and monster attack value, which is an integer. And I can actually get rid of player health and monster health here, and only create them just in time down there by changing this to a colon equal sign operator in line 47. And with that we got those variables, which we can now also use in the if statement, but also outside of it. That's why I'm creating them ahead of time, so that these variables are available inside the if statement, but also outside of the if statement without issues. And then here I will store the player attack damage if we attack the monster. In this case here, if we healed, I'll store the player heal value. And if we had a strong attack, I'll again store the player attack damage. And once the monster attacked the player in line 45, I'll store the monster attack value. And to be in line with the player attack damage, this should actually also be called monster attack damage. So change value to DMG here. And with that, we're storing this important data that is returned from these action functions. Now, of course, sometimes, for example, if we healed, some of these variables won't be set. If we healed, player attack damage won't be set, for example. But that's no problem, because the default value for these variables is 0, since they are of type int. And that is a perfectly fine default value for us, because that means that later in this struct, we will store 0 as a value for the player attack if the player healed, which makes total sense. So that's an advantage of defining those variables here and using their default values. And of course, that's the default value for all these variables. Now that we got these extra variables back in our struct, we can now also store the player attack damage, and that's our player attack damage variable, which we just added. Then we have the player heal value, which is our player heal value we got here. And the monster attack damage, which is our monster attack damage variable. And with that, we got all that round data. And now I want to pass that round data to print round statistics. For this, we pass it as a parameter value. And very important, my autocompletion did it for me here, you need to add this ampersand symbol in front of it to reference it, so to get the address of that struct. Because here we are creating a struct, and round data therefore contains the complete struct, but I just want to pass a pointer to the struct to print round statistics, because it only wants a pointer. And therefore we have to use the ampersand symbol to get that memory address of the value and pass such a pointer to that function. Without the ampersand symbol, this would be invalid. So let's add it. And with all of that, we now hopefully should have some log information after every round. If we now again run this application, if I attack the monster, we get some output here. That I attacked the monster for 6 damage, and then the monster attacked me for 9. And hence we have these health values thereafter, which makes sense. Monster hit me for 9, so I have a health of 91 since we started at 100. Monster has 94 since I hit it for 6. And we can now, for example, heal. And now you see I healed for 9, and the monster then hit me for 9, and therefore my health didn't change. Now let's test a special attack. And now we hit the monster for 17, and then it attacked us for 12. And now if I heal again, I healed for 15, and it hit me for 10. So we had a net win of 5 health points. Let's maybe attack it then, launch a special attack, heal again, and launch another special attack. And you see those values differ. So now we have real random numbers. And then attack the monster again, and heal, and special attack, and heal, and attack, and special attack. And now you see player health is 23, monster health is -2, hence the game is over, and hence the player won. And the game ended, and we're back in the command line, and we can run regular command line commands again, because the application finished. So this all seems to be working, and we now also got some information after every round, which of course is quite useful, because otherwise it's not that much fun to play this game if you don't know the health amounts and so on. So now we're logging all that data for the different rounds. Now we really got only one functionality missing. And that's the functionality to write some log into a file, so that we don't just have to log messages whilst we are playing the game, but we also got the extra log file once the game finished. And for that, to achieve that, I want to go back to output Go, because again, we want to output some data, but this time not into the command line, but instead into a file. So in output.go, maybe at the very bottom, doesn't matter, I'll add a brand new function, which I'll name writeLogFile. And here I want to get my, data that should be stored in the log. And now the question, of course, is which kind of data should that be? What do we pass to writeLogFile? Well, in the end, if we think about it, it should just be multiple round data struct instances. We have one round data instance per round, and if I want to create a log file that covers all the rounds, I should get a list of such round data struct instances. Or in Go's world, an array or slice. And that indeed makes a lot of sense, receiving an array or slice of round data structs here. Now what's better, an array or a slice? We learned that an array is fixed in its size, whereas a slice can be dynamic if we use it to create such a list. And here we clearly want a dynamic list because as a developer we don't know how many rounds we'll need. This game can last for over 100 rounds probably if you just keep on healing yourselves, and it can also end after 10 rounds or something like that. So we don't know in advance how many rounds we'll have, hence an array would be the wrong choice because we don't know how many entries we'll need in that array. That's why instead in write_log file, I want to get my rounds, and that should be of type slice. So here I'll refer to the round data struct and add square brackets in front of it. This tells Go that the type of data I want here is a slice, so a list of round data, a dynamic array, so to say. And to be very precise, I want to get a pointer here to again avoid unnecessary copying. That is optional though, you could also accept the slice value as a whole. Now, before we work on the actual logic for writing that slice data to a file, let's go back to main Go and manage that slice of rounds there. Because it's main.go where we create our round data struct, so it is here in this file where I want to manage this slice overall. And I'll do this at the very top where I also manage the current round. There, I'll add a brand new variable, the rounds, or the game rounds, however you want to call it, and that should initially be an empty slice. And for this, I'll refer to interaction round data, because it will be a slice full of round data instances. And since it should be a slice, I'll add square brackets here in front of it. And since we're on the right side of the equal sign, we don't want a type here, but a concrete value, and hence I'll initialize an empty slice like this. So now with that, we create a brand new slice of type round data, so full of round data instances, but initially it's empty. But since it's a slice and not an array, we'll be able to add new data, new round data instances dynamically. And that's what we'll do in our execute round function now. Here we build this round data instance and we then print it. Well, we can then of course also add it to our game rounds slice which we just created. So this variable we just created. We can use the built-in append function to append a new value to this existing game rounds slice. And that new piece of data is that round data instance which we created here. And then append returns a brand new slice which has an updated capacity, and that's then what I want to store back into game rounds, so that I override game rounds with this brand new slice. And with that we are managing that slice of data. Now back in endgame, besides declaring a winner, we can also reach out to the interaction package again, and now also call write_log file and pass game rounds to it, or to be precise, pass a pointer to game rounds to it, since write_log file wants such a pointer. And now we'll also trigger that function here in output Go. And with that, the last missing piece now is that we add the actual logic for this file. The logic where we go through all these round data pieces in our slice of round data pieces, and we then somehow write this into a file. So how can we now write that data into a file? Well, first of all, we need to create a brand new file. We also did this earlier in the course already. And then we need to step by step write different lines of data into that file. Now for creating that file, we can use the OS package, which you need to import therefore. So make sure you have that import added in the output Go file. And then with that imported on that OS package, there is a create function which creates a brand new file. And here I will name that file gamelog.txt to create a file with that name and extension in our project directory. Now OS create will then actually return two values, and that's either the file or an error. And hence I want to check if the error is maybe not nil, which means we have an error, in which case I want to output some information like saving a log file failed. And then I'll say exiting, because then I'll just return here, which means we won't write that log file. Instead, we just exit. And yeah, we unfortunately have no such file because creating it failed for some reason. But if we make it past this if check, we have a file and we can now write data into it. And here we now want to go through all the entries in our round data slice and write those entries into that file. And that again screams for a for loop. But this time not a for loop with a condition as we had it before multiple times, but instead a for loop where we loop through all the entries in this round data slice. And we can do that with this special range keyword, which I introduced in the control structures section. And this range keyword is used on our rounds, though we need to dereference it, because rounds is a pointer, and here we need the value. And then when we use range, we get back two values. We get the index of that item and the value of that item. And then we can loop through all those items in that list like this, with the colon equals sign operator in between. So that will now go through all the entries and give us the index and value of each entry, and then we can write that entry into the log. The question now just is, what does write that entry into the log mean? Well, we do have that file, write string function, or method to be precise, which we can execute to write data into that file. But as the name implies, this wants a string. And here we just get some round data struct value, which is not a string. So to write this, we could just convert this struct to a string with format sprint. That takes, for example, a struct and then converts it to a string. But I also want to practice using maps again, because this actually is a quite decent use case for using a map. We have some pieces of data. Every round data has various pieces of information, which we might want to group together into one collection. Maybe also enriched with some extra information, for example, the index, which in the end is the number of the round. And therefore, I'll add a new log entry variable here, which should hold a map, which we can create by using the map keyword. And then we define the key value type, which here will be string, and then the value types, which are also strings here. And then I'll use that map literal notation with the curly braces right thereafter to create a brand new map here and immediately populate it with some values. And here we can now, for example, add a round key. Key name is up to you. And that should store index +1. Index +1 because index starts at 0, but the first round, of course, should be 1 for us humans. That's why I add 1 here. The problem is that this would be an integer, and we want a string here, but we can convert this by using the format package and the sprint function. This converts a value to a string and returns a string, which then is stored as a value for this round key. Now we also might want to store the action identifier, and for that we can use value, which is our round data struct in the end, dot action. We also might want to store the player attack damage with a human readable key like that, which is value dot player attack damage, but that's an integer again, so we want to convert this with format sprint. And then I'll copy that line to also add the player heal value if we have that, and that should be value dot player heal value. And then I'll copy that again so that I also have the monster attack damage. And here we then convert the monster attack damage. And then we have some health. So we got the player health here. And hence here we have value.player health. And then we repeat that for the monster health. And hence we access value.monster health. And now we got this log entry map with our custom, a bit more human readable keys and their respective values. And that's not just our struct again, because I also enriched it with this extra round information and I made those keys more human readable. So now we have a map and we can now easily convert this to a string by just adding our log line maybe variable, where we again use format sPrint, or to be precise sprintln to add a line break automatically. And we pass log entry to that. The great thing about all those sprint functions is that just like their regular print equivalents, they basically take any kind of values and Go will give us a string representation of those values. And with that, we can easily convert a map object into a string. And then it's this log line which we can write into our file, which is this string version of this map. And you'll see how that looks like in just a second once we start executing all of that. Now, writing into that file could fail, and therefore what we get back is actually two pieces of data. We'll ignore the first one, but the second one is the potential error which we might get. And here I therefore also want to check if the error is unequal to nil, which means writing into the file failed, in which case I want to output some error, where I say writing into log file failed, exiting, and I then return again. Alternatively, we continue with the loop and we see if we succeed writing the next entry. That might also be worth a try. Let's maybe do that so that we also see the continue keyword again. And then once we're done, once we make it out of this overall loop here, once we wrote all the entries into the file, I want to close that file by calling close on the file. So to close the file access. And then I'll output another message and say wrote data to log, like this. And with that, we now got all that logic in place here for going through all our pieces of round data, creating maps based on those different structs, and writing that map data into our log file. And therefore, with that, it should now hopefully work. If we execute our program again, I can now attack and heal, and special attack and heal and attack and special attack and heal and special attack, and so on. Whoops, invalid input. So let's continue. And we won. And we see that wrote data to log output, and we also see the game log text file now. And here you now see how that looks like. This is the string version of that map that we created, and it contains all the data we added there. Of course, you could play around with formatting this differently by not using a map and instead formatting your own strings, but I think that's a quick and easy way of storing that data here. And you see that the round numbers are stored as well, and overall, I would say that is a nice log that finishes up our game, and with that we added all the different pieces of functionality that we want to add here. Because now we got this working game, we got the different actions the player can perform, and we're also outputting all the information the player needs to know to play that game. Now that's it for this main project. I will say right away, there are many other ways of writing that same project code. You can solve all the different steps and problems in a different way, and you will definitely be able to come up with improvements. My goal here, of course, also was to again practice all those key concepts which we saw throughout the course, and I hope that therefore now, once you finished this project, if you also finished all the other course sections, it's clear how Go generally works, and you do have a decent overview of all the core concepts that make up Go. With that, definitely feel free to go through this project again, this time totally on your own, to again practice what you learned. Even now that you saw the solution, chances are high that there will be some parts where you do struggle again, especially if you maybe wait a couple of days until you try it again. And then, therefore, this would be another great practice for making sure that you really understand all these essential Go basics. To conclude this very thorough introduction into all those important Golang basics, in this course section we are going to explore how you can add third-party modules, so external code, into your project, since that is something we haven't done up to this point. We only worked with the built-in packages. Now we'll see how we can also include modules and packages written by other developers. And we will learn how to build our apps so that we can build standalone executables that could be shared with other people. And for that, we'll start by looking at third-party modules, what exactly that is, and how we can add such modules to our project. And we will then explore how we can build our application to work as a standalone executable so that we don't need Go installed to execute it. And whilst we'll do that, and when we test this executable, we will also have a look at an important gotcha, which can cause some problems, but which we will fix in this course section. Now for this section, I will use this Monster Slayer project on which we worked in the previous course section, and I want to enhance it a little bit. Here, when we output data, when we output information, I actually don't just want to output information the way we are currently doing it, but instead I want to show some ASCII graphics, some text graphics. To be precise, I want to show this game over text in declare winner as a nice ASCII graphic, and I want to show the Monster Slayer title in print greeting as an ASCII graphic. And in case it's not clear what I mean, you can search for ASCII art. ASCII is simply a character set, so the characters you use in your code and in your text. And you can draw pictures or graphics by combining those characters in a certain way. You can also search for ASCII graphics to find more information about that. Now, that's not Go specific, that's a general thing in the internet and computers, I guess. But I'd like to draw Monster Slayer and Game Over in a more fancy way by building such ASCII art. Now, I could do all of that on my own, and I could try to build a G by combining certain other characters, but even better than that, I can also use a third-party module to achieve this. Because up to this point, we only used built-in packages like format and OS. And indeed, one of the main ideas of Go is that we have a lot of built-in packages that allow us to achieve a lot of things, like getting user input, cleaning user input, writing to a file, generating random numbers, as we're doing it in actions.go, and much, much more. So there are a lot of built-in capabilities, but not everything is built in. Sometimes you want some functionality that's not built into the standard library, so that's not part of Go itself. And then you either have to write the code for that on your own, which often is an option, but sometimes you don't want to do that. You don't want to reinvent the wheel to solve a simple problem, and therefore you might want to reach out to third-party modules. And in Go's case, what you can always do is you can search for Golang and then describe the problem you want to solve. For example, search for Golang ASCII art. And if you do that, you will find various posts and GitHub repositories that might help you with that. For example, here, the first search result that's proposed is this GitHub repository, Go Figure, which seems to contain some Go code that helps us with displaying ASCII art in our Go programs. A little bit further down, I also find this ASCII art package on package.go.dev, which also could be interesting. Now, here, however, I will stick to this Go Figure repository and click on that. And then here I learn that this can actually easily be added to a project, and I can easily use it in there, import it, and then, use the features built into that module and package. And as you can see in this code snippet, we import it just as we import our own modules and packages in our project. We have this module identifier, and then we point at a certain package. And it's the same here. We have this identifier here, and then this module doesn't have any sub-packages. Therefore, here the module identifier is already pointing at the main package. And we also get more information here, more documentation on how we can use this package if we add it to our own project. So what we could do here is we could run this command to install this third-party module into our local module and make it available there. Or you can actually even skip this step and just grab this import path. So simply this module identifier here, copy that, and then go into the file where you want to use it, which in my case is output.go, because there I'm showing that text. And here in the import statement, I just add this identifier. Now that alone doesn't immediately make that package available here. But we can now go to print greeting and start using this package nonetheless. Here we can use figure, not go figure, but just figure, because that's what we also see in the documentation here. And we can create a new figure as shown in the documentation by executing this new figure function here, to which we pass the text Monster Slayer in my case, which should be displayed as ASCII art. Then we got other parameter values which we have to pass in, so I'll just copy that here and add that as well. You could, for example, set a custom font here if you want to, but I'm fine with the defaults here. Now, if you do that and you save everything, you will see that we got errors here because we have an identifier which at the moment is not recognized by Go for this project. It doesn't automatically reach out to that URL and search the code there. But we can now run a command here in our project folder. We can run the go mod tidy command. Now what the tidy command does is it has a look at all your imports, and it looks for third-party modules that might not have been loaded yet, or for third-party modules that you might have loaded in the past but aren't using anymore. Now here we got a third-party module, because it's not one of our own identifiers, which hasn't been loaded yet. So if I run this command, you see it goes ahead and finds that package, and it then actually updates the go mod file and adds this require statement there, which basically makes Go aware of this dependency of our local Go module, so that our own Go module with this identifier now also depends on this third-party Go module here. And it also locks in certain versions here in case there would be different versions of that package and you want to depend on a very specific version. It will depend on the package you're using, which versions have been published. We also got a Go sum file, which you can ignore. This just holds some metadata information used by Go for loading this package. Now with that, now this package was loaded, and now you will see that if we use figure again, we now also get auto completion here. Now, of course, it could be annoying to first type some code and then run go mod tidy, and that's why we also have this go get command here, which is also shown in this repository. This would simply download and save that third-party module right away, so it would add that entry to go mod right away, and we could then start importing it and writing code right away, and we would get auto completion right from the start. Hence, running go get can be a bit more convenient, but I wanted to show you both, go get and go mod tidy. Now with that here, we are creating this ASCII figure. So here I got my ASCII figure variable, which stores the returned value. And now instead of printing Monster Slayer here in line 21, we can use the ASCII figure and run the print method on that to print that figure. And with that, if you now run your program again, you will see that now we got this ASCII art here, Monster Slayer. And it's quite huge because I'm zoomed in quite a bit here. If I zoom out, it's readable. And that's now this text as ASCII art. So multiple characters and lines combined together to display this graphic, automatically done by this third-party module. And now I'll do the same here, hence I'll copy that, in the declare winner function. Here I want to show game over, so I will use game over as a text here. And we can even create a colored figure by using new color figure. We also get auto completion for that, so that's a built-in function. Here we then just also have to define the color as a third parameter, and here I'll simply use red maybe. You can use an identifier like this here. Again, you find more information in the official documentation if you want to. And with this, if I now run this again, you see we got the initial graphic, which is not colored. But then if I play this game, here I'll just attack a bunch of times, I then also get game over, and here it's colored in red. And that's how you can use third-party modules. And this is, of course, an important piece of knowledge, because if you're going to build more complex, bigger projects, you are often going to use some third-party packages and modules that may contain certain helpers or functionalities that you need in your project as well. Now, working on your own module and your own project is nice, but at some point of time you might want to share it as a standalone application with other people. For example, this game. We don't just run it for ourselves here with the go run command, which is really just a command that we have to test our application during development, but instead we might want to share it with other people, including people that don't have Go installed. So we don't want to share our code and force other people to then use the go run command, but instead we want to get an executable, so one single file that contains all that combined code that can be executed anywhere, including machines where Go is not installed. So we need to compile this Go code. That is what Go run does as well, behind the scenes, so to say, but now we want to do it explicitly to compile, so combine and convert all our source code into one standalone executable that then doesn't depend on the Go software to be installed on a system anymore, because compiled also means that our Go code has been translated into machine code, basically. So it runs natively on our machines without extra software to be installed there. And Go has a built-in command for that. There is the go build command. If you run go build in your project folder, then this will create an executable file. So if I run that, I get no feedback here, but in my folder I now have this Monster Slayer executable file. On macOS and Linux, it's a file without any extension. On Windows, this would be a monsterslayer.exe file. Either way, it's executable, which we can double-click to execute. And not here in VS Code, because here double-clicking just opens a file to be edited, which doesn't work for this compiled file, but in our regular Finder or Windows Explorer. So here, in my case, on macOS, if I open this project folder in the Mac Finder, I got this Monster Slayer executable here. Now let's try executing that, and for that I actually don't want to keep it in this folder, but I want to move it somewhere else. In my case, I'll move it to the desktop. And to be precise, in my case, I then also moved it into a subfolder there called Golang. Now, no matter if you are on macOS or Windows, you should now be able to double-click this. And no matter on which operating system you are, this should open a command window in which that file executes. And here we can now play that game as we did before. So I can attack and heal and special attack and so on. That all works, as you can see, but you'll notice a problem. It works and it then ends and we can then close this window, but you might recognize that the log file is missing. We'll fix this in the next lecture, but if we leave out that issue, we see that it works just fine. And indeed, this is how you can build your Go project to be a standalone executable, which you then can share with other people, simply by sharing this executable file. But now let's have a look at this gotcha and what's causing that and how we can fix that. As shown in the previous lecture, this log file is not being created here in the folder where I have my executable. Instead, this file probably was created somewhere else on your system. Now, during development, it always was created here in our project folder. And here I'll delete it. This was not the file that was created a few seconds ago in the last lecture. This was an older log file. So the log file is missing. And during development, as I just said, it worked fine. The thing here is that once we build an executable, Go unfortunately does not take the folder in which you execute the executable as a path for storing your files or any files the executable might be interacting with. But instead it will be using some other directories on your system, which then in turn depends on which system you're on and your system settings. And this is not the behavior we want here. Therefore, to finalize this application to also work once we build this as an executable, I'll go to output.go and tweak this write log file function here a little bit. Just specifying the file name here when we create that file is not enough. Instead, we also need to specify a full path, an absolute path to that file, and that should be the path to the folder where the executable can be found. Now, thankfully, Go makes that quite easy. We can use the OS package, which we already are using to use that create function, to then execute the executable function there. Now, executable, this function, returns a path to the executable file. So if we move that standalone executable file, which we created, into a different folder, this will give us a full path to that folder, and it will also include the file name. So executable gives us a full path to that folder with the executable, including the executable name. And we'll get rid of that name in a second step. But for the moment, that's a huge step forward because that gives us a way of getting an absolute path to the folder in the end where this executable resides. And that is exactly what we need here to then ensure that we are able to create our text file in that same folder. Now for this, we just need to use the path, and here we get the executable path and also potentially an error because determining this path can fail. And hence I'll check if error is maybe not nil, which means we have an error, in which case I want to output writing log file failed, exiting, and I want to return and not continue, but it should typically succeed. And in that case, we can use this executable path and then just point at this file, which should be created in that path. However, we won't be able to use the path just like that. Instead, we need to use another built-in package, the file path package, which you therefore also need to import. It's a sub-package of the path package of the standard library built into Go. And with this file path package, you can then execute the dir function. We need that to prepare this full path to the executable correctly, because this full path contains the executable name itself, and we need to drop that name, and therefore dir gives us the directory that holds the executable. This actually gives us that directory and then includes the executable name itself into the full path. That's why we need dir to get rid of the executable name and just convert this path to the executable, including the name, to a path to the directory that contains the executable. So here to dir we pass xpath, and then we can overwrite xpath with that cleaned path here. And now we can construct a full path to the file that we want to store. Because create does not just take the standalone file name, but it actually takes a path to the file that should be created, including the file name. Now, before it was fine to just pass the file name, since it then automatically took that project folder, but as I showed, that's not the case once we run an executable. Hence, we now use xpath, which is an absolute path to the folder that contains the executable. And we combine this with game log text and add a slash here, which is required to ensure that this game log text file is really created in that folder that also contains the executable. And with that, we now have code that should work with the standalone executable and that should store our game log file next to the executable. Now, it is important to note, though, that this code now won't work with go run. It won't crash, but it won't store the log file in the project folder anymore. So if you want to test this with go run again, you need to go back to the previous code where we just created this with the file name. So you need to go back to this code and comment out all that code. So that's required for go run. But it should be fine to switch to this code now, since we tested our code extensively and we're done testing. And since we now want to build it as an executable, we can switch to this code to finally prepare this code to work with the executable and to then build that standalone executable successfully. There also are ways of writing code that works with both an executable, so a standalone executable and go run, but that's a bit more complex and really not necessary here in my opinion. Nonetheless, I'll attach a link to some blog post that discusses this problem and some potential solutions in greater detail in case you want to dive into that. Now with that though, here we can run go build again to build our executable again. Here it is. And we can now again test this executable again. For this here, I replaced my old executable with the new updated one. And we can execute this again and just launch a couple of attacks here, doesn't matter too much. And now that I lost, you also find the game log text file here next to the executable now. And in there we got our log data. So this is now working, and now we are able to write that log file into the same folder as our executable resides in. And that is a gotcha you should be aware of when working with files if you plan to build your Go app as a standalone executable. This is how you can make it work.